also there, in modular blockchain, the different protocols with different interests are integrated. So there are some business concerns. So if some problem in edge case happens, then there might be some conflicts of some incentivization or the responsibility issues. And the second case, when we use rollup as a service, I think it can be easy because there already exist using some layers. So only when it's very well organized and secure through security audits, and I think it is a kind of makes sense. So we should think whether the modular blockchain architecture can solve every issue of the current world. So let's think about the Arbitron's transaction flow. The right figure is the figure I draw for my research article for some finality issues. But as you can see, sequencer takes in charge of very critical functionalities, including collecting and ordering transactions or simulating the transactions through local VMs to check the validity of the transactions, or publish the L2 blocks in the proof of batch. And also in Arbitron, they are validated by 14 whitelisted validators that challenge and validate the transaction. And also there exists some security council elected by Arbitron DAO. They can update the critical contracts of the Arbitron without any delay. So as you can see, Arbitron's architecture is indeed centralized. However, if we substitute the Arbitron's architecture into a kind of modular blockchain, then does it can solve every problem of the existing tools? And I think it is not, because every process is very critical, including the sequencing and proof generation of proof publishing or the execution. So in modular blockchain, multiple protocols are integrated and their roles, these critical roles are kind of distributed into the different products. So I claim that there might be some multi-points of failure rather than the single point of failure in existing L2s. And also, as different protocols with different interests have integrated, as I said earlier, there might be some interest conflicts between some incentivization and also the responsibility issues. And also as different entities operate at different layers, some protocols often implement the off-chain relayers for the communication of each layer, and this makes another point of failure. And also, the third problem aligns with the second. As different entities participate in executing some transaction, this requires multiple validation. So if some problem happens, then you need to find out whose fault it is. So we need to validate some transaction inclusion of the executor or sequencing proof of the sequence. And also, as the validation process is very critical in maintaining the integrity of the chain, validation might be implemented in permissionless manner, and it has a very much implementation challenge. So, I have thought about the risks that remaining in each layer. So I'll start with the sequencing layer. So in some modular blockchains, there still remains the centralization issue. In case of the dimension, they whitelist the multi-sequencer, which is selected by the governance of the rollup. So we all know that most of the governance in blockchain does not work really democratically because economic value is very centralized in the operator side. So in this case, there might be a certain level of centralization, and I wonder if you can solve this problem. And the second one is malicious sequencer. And as some some implementation does not verify if the sequencer has intentionally delayed user's transaction. And you might think this is a very minor issue, but you all know that in finance, time is gold. And also, the last problem is handling the spam transactions. Because validating a transaction's validity is significantly expensive than just sending a trash transactions. Decentralized sequencer might be very stressed to validate those spam transactions. The next one is the execution layer. So, as I mentioned earlier, as execution layers often toss the block data to the DA protocol, there might be some middleman implemented to relay the block data to the DA layer. So the execution layer might publish a proof that the data block they published is valid. So I think there should be some semi-pessimistic approach on the validation. The next one is the integrity check of the actions. In some protocols, assist that they have implemented some app chain ecosystem, and they usually provide software development kit for some easy development of the app chains and rollups. However, when the core functions of SDK is revised for their own functionalities or their malicious intention, then we need to verify if the integrity of the rollup, and also we need some dedicated quality control of those. And the last one is the problems of the alternative VMs. So we know Eclipse that utilizes the Neon VM. Neon VM is a kind of parallelized VM that converts the Solidity compiled bytecode into the Solana VM bytecode. And we can think that this can raise some issues because of the Solidity compatibility and also the misimplemented some EVM compatibility issues. And also the alternative VM's vulnerability is kind of similar to the Web 2 side rather than the Web 3 side. There's significant lags that can audit properly for those alternative environments. And the next one is the issues of settlement layer. The biggest problem in the settlement layer is implementing proper fraud proof that is decentralized. So building a fast, loss-resistant fraud proof system is very hard, and major wallets are currently struggling with this. So in case of Arbitrum, they have implemented permissionless fraud proof called Vault, but they're not integrated in the mainnet. And also in case of Optimism, they have also implemented their own fraud proof called Canna, but they have found there were some critical vulnerabilities in it, and Optimism had re-implemented, and it is recently in the competitive audit phase. So as I said, multiple protocols are integrated in modular layer. So it often requires some additional fraud proof for each layer. So some problem happens, like when sequencer and block producers are different, and something happens with the block data, then how we can verify it is someone's fault. So we need to implement multiple fraud proof system, and it also introduces some implementation challenges. The next one is the DA layer risks. So DA layer is very critical for the scalability and security of the modular blockchain, because DA enables the fast finality and also the security using the cryptographic proofs. However, it is based on the cryptographic proofs. There are very few projects that can implement them properly. So there are little number of protocols that implemented DA layer rather than the other layers. And those include Celestia, Avail, and IDTA and NearDA. And because it is based on cryptography, also lacks auditors. We all know that auditing ZK is very hard, and it is applied in the same manner. And the third one is my personal question. The DA proofs are usually based on two-dimensional green-salad proof, and these have quadratic cost for the data size. So I think using the DA layer for large size data and some fraud proofs can generate some incorrect data. This is my personal question. So, yeah. And the last one is the DA problem. As data availability layer gets like underneath every protocol, when data availability layer fails, then multiple projects will suffer the same problem. So some DA protocols are currently implementing the fallback system, which fallbacks into some Ethereum or other DA layers when their DA layer fails, but they are still in the development phase and not integrated in their main. So I have told you about the risks of each layer. So now what? You may say you just pick the issues, but you do not provide the solution. So I think the solution, one of the solutions would be the ZK optimistic hybrid approach, because the blockchain integrated with multiple protocols. The optimistic approach is too optimistic for the modular architecture. So I think we need to provide some semi-pessimistic value proof approach. And the second one is building a security infrastructure. As DA layer did, I think we need fallback system for every layer. And for the user security of their funds, I think exit hatch for every modular blockchain is critical for their implementation. And third one is making the risk template of modular blockchains. Some of you kind of know the L2 bit, which analyzes the architectural risks of the L2 blockchains. So for modular blockchain, this does not exist. So I think somebody is building this, but currently there's nothing. So I think risk template for every modular architecture is very important to acknowledge users to the risks of the protocols of their risks. And also, security consulting is kind of needed from the design phase, because architectural risks are often not solvable through the code revision. And even if it can be through the code revision, it would be some ephemeral patch, which is not very clean and very dirty code. And lastly, I think very well organized rollup framework or rollup as a service might be a solution, because it is very essential for the mass adoption of modular architecture, because we need to trust that the chain deployed with those framework is safe. So I think Initia would be the key player of those systems. Yeah, so this is the conclusion. So I think modular environment is in very early stage, and also each protocol does really care about the security measures, but in integration phase, I think it is not. We need L2B for modular chains. And lastly, I believe modular blockchain would lead the trend of the next phase of Web3, but we should mitigate the mass production of low quality tools in this kind. So thank you for listening, and if you have some questions, please follow our SNS and also mine. Thank you.
If anyone has questions, please feel free to ask me one and emails.
네, 됐습니다.
모듈러
모르지만 제 개인적인 생각으로 말하자면 이 모듈러 블록체인이라는 게 프레임워크화가 되면 이 모듈러 체인을 쉽게 배포하는데 상당히 유리할 거예요. 왜냐하면 지금 뭐 L2를 새로 만든다고 하면 뭐 아비트럼을 새로 만든다고 생각하면 돈도 많이 모아야 되고 밸리데이터도 모집해야 되고 되게 많잖아요. 그래서 뭔가 경제적인 관점으로 접근했을 때는 이 사람들이 아이디어가 있는데 체인을 배포할 능력이 못 되는 경우 이런 경우들 좀 많이 해소할 수 있지 않을까라는 생각이 듭니다. 네, 이건 물론 안전한 구조로 설계되었을 때 그런 느낌이에요. 네.
내가 시퀀싱 레이어를 만들겠다고 했을 때
네.
사실 DA 레이어는 신경 안 써도 된다는 거예요.
아니요, 그건 아니죠.
똑같이 DA 레이어도 신경 써야 되고 다른 레이어도 신경 써야 되는데 그거에 적합한 시퀀싱 레이어를 해야 되는 거는 어차피 다 알아야 되는 구조를 다 알아야.
맞아요. 그래서 시큐리티 컨설팅이 필요하다고 한 거거든요. 그래서 뭐 어떤 내가 시퀀싱 레이어를 개발하겠다가 아니라 내가 어떤 체인을 개발하고 싶은데 시퀀싱 레이어는 이거 고르고 싶고 엑시큐션 레이어는 이거 고르고 싶고 밸리데이션은 이거 고르고 싶다라고 했을 때 컨설팅을 받아서 아키텍처 리스크를 좀 해소해야 된다는 말입니다. 물론 시퀀싱 레이어를 개발할 때 다른 레이어들을 신경 써서 개발해야 돼요. 네, 그래서 지금 시퀀싱 레이어도 상당히 구현이 어렵고 네, 많이 나온 프로젝트들이 없죠. 네, 안전하게 개발된다는 전제하에 네, 미래는 있다고 생각합니다.
Yeah, if there is no more question, then let's move on. So thank you for the first speech, Calvin. And we'll have our next speakers. So please welcome Nick White from Celestia and Hee Chang Kang from Warblers.
Hello.
Hi. Yeah, I'll just start off. So for this part right now, we're just going through our main speech. We'll be about like past and present and future of modular harmony. So we're just gonna have a chat with Nick since he's one of the OGs in model blockchain and has a lot of knowledge in that field. So yeah, happy to have a chat with Nick. And do you want to introduce about yourself a little bit?
Sure. So I'm Nick. I'm the COO at Celestia Labs, and we're building. Are contributing to building Celestia, which is a modular blockchain network. It launched last year in October, and essentially what Celestia is it just focuses on data availability and consensus. So essentially it's a layer one that's built to scale and secure rollups and L2s. So unlike other layer ones, Celestia is modular, it doesn't do any execution, has no smart contracts. All it does is it's sort of like a publishing layer for the rollups to publish their transaction data. We really believe in this whole idea of modularity for blockchains because it solves some of the core problems of blockchain infrastructure. It makes them more scalable, it also makes them more flexible, it enables developers to customize their own execution environment and capture more of the economics of the applications that they build. So we think that modularity is a really big step forward in terms of building blockchain infrastructure that's going to take us to the next level.
Yes, so just diving more deeply into this sector, I just want to talk about the Initia
how we got here. So first question would be about like Celestia is one of the first projects that combined and then built the narratives around the modular blockchains. So from my knowledge, it started with a paper written by Mustafa, who is one of the CEOs of Celestia, and Vitalik, and then Sonam, who is currently a chief scientist of Initia. So can you go through a little process and your like thoughts on how Celestia started and why you guys have started building the Axelar first?
Sure. So I think the paper, there's a couple of really landmark papers. I think the one you were talking about with Vitalik and Alberto was the data availability sampling white paper. I think that was a really important paper, but it wasn't necessarily the origin of modularity. I would say the origin of the idea of modular blockchains came from the lazy ledger white paper, which Mustafa sort of wrote on his own. But basically, and actually I read that paper in 2020. I really encourage everyone to read it. It's called the Lazy Ledger White Paper. And to me, when I read it, immediately the brilliance of this idea. We didn't really have we weren't using the word modular at that time, but this idea of building a very, very simple layer one and letting all the execution happen, a separate layer was just something that immediately struck me as beautiful, because people have been trying to solve some of these fundamental problems of scalability in blockchains for a really long time. There was, how many years of people building and researching sharding solutions, people like Solana, which were just trying to really optimize a single, blockchain and how fast one single, shard could go. But no one had, all those solutions kind of shared the same pattern of trying to solve the problem by making the system more complicated and trying to add new layers of complexity and optimizations, whereas lazy ledger, the idea of modular blockchains, was actually to go a completely different route and actually simplify things. And so it was just so beautiful that you could solve all these problems by, instead of getting more complicated, getting more simple. And so after I read it, I couldn't sleep for 2 weeks, because I was just so in love with the idea. And the more that I learned about it, the more it made sense. And so I think the paper was published in 2019, and then so it was about 4 years between when the paper was published to when the network was launched. But I think the idea of modularity really started to be used more frequently around 2020 and 2021. That was when kind of the word modular came to encapsulate this idea of separating the functions of a blockchain into separate layers and protocols.
Yeah, it was quite interesting and great to hear Nick's thought on this. And he also talked about more on the technical architecture of blockchain, and it's necessary for having model blockchain concept to be implemented. But getting a little more high level, I just wanted to hear how Celestia have built the community around model blockchain, because I think Celestia is one of the companies that have really built marketing and community in more agile and then more cohesive way. So what kind of community activities or marketing efforts did you make to make Celestia known and then model blockchain concept narrative?
So I think Celestia and the idea of modular blockchains is just fundamentally innovative and a good idea from a technical standpoint. So I think the idea kind of marketed itself. I mean, we put a lot of effort into coining and using the term modular, and to trying to point out how modular was different to everything that came before. It was a new category of blockchains. And I think it was important to label the other blockchains as monolithic, so that we can kind of establish the difference. And so I think that was one of the important things, was sort of categorizing monolithic and modular, and explaining what the difference was. So I think that was an important thing in terms of like helping people understand what Celestia is and what modular blockchains were. But I think the reality is that, and we had to do a lot of education. So for for 2 years, we were just like constantly trying to explain the idea over and over again in different ways, because modularity itself is simple once you get it, but it's hard. You have to understand the fundamentals of blockchains for it to make sense. And the reality is that a lot of people don't actually know the fundamentals. So like it was almost like to explain modularity, you had to also teach people how blockchains work under the hood. So that made it a little bit harder. But I think the idea of modularity and modular blockchains markets itself. It nerd snipes engineers and technical people sort of organically. Like that's how I got into it. It's just reading the white paper and I was like, wow, this is really brilliant. I think I've seen that pattern play out where once people get it, they won't forget it, and they get they fall in love with the idea. And I think the best ideas always have that kind of pattern. If you think about Bitcoin or Ethereum, there's a similar pattern where people, once they learned about what Bitcoin was and they realized that it worked, they couldn't let it go. And I think similar to Ethereum, when people realized the powers of smart contracts, they would just naturally be attracted. And I think modular blockchains have a similar component to that, in that they just, once you get it, you can't unsee it, and you're just like, wow, okay, I'm doing anything that's not modular feels like, taking a step backward.
Yeah, so I think from the initiation of modular blockchain, really a lot of people got grasped into it and then started developing it and writing pieces and writing research articles related to it. And currently, from my knowledge, and we recently, last year, wrote Modular Odyssey, which lists all the modular blockchain projects and the architecture of it. So from current perspective, there are a lot of modular blockchains being developed and being launched in production. So out of them, do you have some projects that you are really looking into and think is really innovative?
That's a great question. I think Celestia is very incredibly neutral, and so we don't have any favorites. But I think what's really interesting about the evolution of the modular blockchain ecosystem is that we always had the 4 main layers of the stack, like data availability, consensus, settlement, and execution. But it's cool that there's actually even more sort of modular layers that are emerging. Things like proof generation networks, proof aggregation layers, shared sequencers, and things of that nature that are kind of emerging as their own layers of the stack. So that the stack is actually bigger than maybe we initially thought. And so I would say another thing that's interesting about modularity is that in a monolithic context, there's probably just one core development team, or there's just one protocol, and kind of only one team that's incentivized to solve all the problems. And you can only try out one single design at a time, because there's only one version of that protocol that can be live. But in modular blockchains, you can have multiple teams building multiple different solutions to the same problem. And it's not that there is no optimal solution even to, let's say, data availability or to sequencing, and it's about having that diversity in the market. And it's a good thing to have multiple solutions to a problem. And furthermore, what's interesting is that in the modular blockchain ecosystem, you can actually launch chains that take advantage of different components. You can try all these experiments in parallel and see which recipe or which combination of these different components actually achieves the best result. And so I think, and again, rather than being competitive, in a monolithic context, every protocol team is in competition with each other. In the modular stack, you might be in competition with people at your layer, but otherwise everyone else is an ally, essentially. And so it's much more like collaborative, positive sum ecosystem. And there's so many different things to build that there's no shortage of fun, cool problems for people to jump in and solve. So that's, I think, also why the modular ecosystem is just like has grown so rapidly, because there's no gatekeepers, and it continues to grow even interestingly by looping in pre-existing ecosystems. Like, you know, modularity is now sort of has infected Bitcoin, the Bitcoin community essentially. Now there's all these L2s being built on Bitcoin, and Bitcoin is one of the oldest, biggest, you know, communities out there. And even Solana, I think, is starting to get like looped into modularity, kind of ironically. But you know, now their community is talking about L2s, and modular blockchains also can kind of harvest all the best innovations and technology from pre-existing stacks. So like the Solana virtual machine is a great, really performant execution layer. That technology doesn't have to be siloed and stuck within the Solana L1 protocol. It can be taken and then repackaged as a modular component so that everyone can benefit from it. And so, yeah, I think that like the modular ecosystem is going to be it will be the biggest ecosystem in crypto because of the nature of it.
Yeah, I just wanted to point out and ask a question related to Solana L2, because I think it's a really interesting question, and the initiation of discussion on Solana L2, I think it started from a founder from Herodotus, because the dApps competitors are competing for the like fees and high fees. So I think that got started from that development of Herodotus. So I was curious about what kind of like steps would monolithic blockchains like Sui and Solana would take in terms of like model blockchains. Do you think there will be a lot of L2s with later soon?
Yeah, so I mean, I would say it's common sense that there's no way that all of crypto or Web3 will ever run on one single blockchain in terms of one single state machine, for a lot of different reasons. First is just the technical scalability of any single blockchain computer is going to be limited. Second of all, for everything to run on one single blockchain, then you give up the ability to have your own sovereign chain, you give up the ability to customize things, capture your own economics. So like, there's so many reasons why the world we will not end up in a world where everything lives on one single chain. Now, that's not to say that it's not a good thing to push the limits of what a single chain, like the scalability or the flexibility of a single chain. I think it's awesome, and that's what teams like Solana and Sui and Aptos are doing. But yeah, I mean, and to my point about technical scalability, Solana is already, their blocks are getting full. You know, they're selling this vision of like, well, you'll never need another blockchain because everything will be able to run on Solana. But the technical reality is right now that it's already failing in practice. And we're not even, I mean, how many users do we even have across the entire world? Like, we're still at like sub 1% of the total number of users that we'll have in the future. And they can't even, like, we can't even run that on Solana. So it's inevitable, basically, getting back to your question, that, I mean, the only way to technically scale is to have multiple blockchains running in parallel. And so, yeah, to me, it's inevitable that, like, maybe the role of a Solana or Sui or Aptos is to be a settlement layer for an ecosystem of L2s that run, you know, move VM rollups or SVM rollups. But yeah, to me, it's like a foregone conclusion that without that, then their ecosystems are just are not going to scale.
Yeah, I think this discussion was really interesting since it started from a dApp in Solana. So yeah, I think diving into the future of like Celestia, do you guys have some more plans to build product other than like Celestia DA? Or do you guys have some like more strategic positioning you guys are planning to do this in Celestia DA?
So Celestia is very committed, not only are we committed to incredible neutrality, we're also committed to being just a pure DA layer and not trying to compete with other layers of the stack or trying to vertically integrate. Because there's a lot of reasons for that. One is that we believe that the purest, thinnest DA layer is going to be has a lot of advantages. It's going to be like the preferred solution. Like once you start to add execution or settlement or all these other things, it has the potential to make that layer heavier and less desirable. And we would rather operate in a world where we are compatible, incentive compatible with every other layer of the stack. And I think we're seeing that play out in the sense of like Celestia can help scale Ethereum L2s and Ethereum can still be a settlement layer. It can help scale Bitcoin L2s and Bitcoin can still be a settlement layer. And like now with Base, we just announced that we're supporting Base L3s with data availability. So I think this notion, the notion that I think we want to like, the message we want to get out to the ecosystem is that Celestia can scale any ecosystem. And so we're not, and if we were trying to build our own separate ecosystem, then that would kind of like, sort of like compromise that promise. And now, the things that we are planning to do, in terms of, protocol, like improving the protocol over time, is absolutely increasing the throughput of DA. I think that's one of the most critical things. Improving light node support so that the block space can be decentralized and verifiable. And then we're adding certain things like ZK accounts. So one of the pain points for Celestia currently is that there isn't a trust minimized way to bridge TIA to rollups. And so by adding ZK accounts, we're basically like an account on Celestia that can verify, you can control funds by verifying a ZK proof. And it's like it will basically enable us to bridge TIA in a trust minimized way to the rollup ecosystem. And potentially even you can build some sort of minor applications like even like restaking type of applications. But a lot of people are like, oh, then Celestia is becoming or wants to become a settlement layer, but that's not all the case because you still won't be able to issue any assets or like bridge assets through the Celestia. That's not what we want to do. It's strictly just for the TIA token to be able to move into the ecosystem on top of it.
So I think the final question that I want to ask you would be about, we're like 5 years later, what kind of like Celestia will be positioned in this ecosystem? You guys will be like more credit neutral and then have it as a more decentralized protocol? Or you guys have some more like initiatives you guys want to push more?
So in 5 years from now, what Celestia wants to be is, the best in class data availability layer, and there's a lot of different, I guess, features or parts of what it means to be the best DA layer, and maybe there isn't strictly one best DA layer because there could be different trade-offs that different DA layers make. In fact, that's almost certainly the case. But I think what best means to us is not only having high throughput, but also being very decentralized and secure. And that means that, like I mentioned, having people actually be able to run light nodes on their phones and verify the chain. I think it also means being extremely reliable and having a good developer experience. So that means having support, like easy support for ZK-based rollups, having really good sort of like Celestia node API that is like something that people count on and can easily build with. And then I think having like a really robust ecosystem of integrations with all the different other layers of the stack, I think is going to be important. But long term, like I think one of the things that's unique about Celestia is that because it's so thin and minimal, it can sort of start to, I wouldn't say ossify, but it can be very stable, sort of like Bitcoin, because we don't really have to make very many changes to the core protocol over time, aside from scaling it and just improving the main offering. But it's very unlikely that we would ever make a change of a great thing to build on top of it, because there's such a thin, the interface is so minimal, and the dependency is so minimal. So I hope in 5 years from now, Celestia is like even more decentralized, and it's perceived as like a very sort of like stable foundation that people can build on for the long term. That's future-proof both, from scalability perspective as well as just like a technical stability perspective.
Yeah, it was really great chatting with you, and I hope you enjoyed Korea.
Yeah, we can take some audience questions if there's time. I don't know if there is.
Yeah, if there are any questions.
Curious about your Celestia core, and you're using the Herodotus or you're using the technology of So I have some just question about your Celestia core. So you use you're basing on using tendon core, or why you choose like the tendon core? Is this only because of using the modularity of system, or like the probability of the ecosystem on the cosmos?
Good question. So the question is, why do we choose to build using Tendermint or Comet, as it's now called? Well, there's a few different reasons. One is that Tendermint or Comet is the most battle-tested consensus protocol out there, and so it's very reliable. Proof, has a lot of proof that it works and is safe. In addition to that, there are a few other things. First is the APCI++ interface made it so that we could customize it, because Celestia is not just your standard Cosmos chain or this is a proof of stake network. There's a lot of different things that we had to do to support data availability sampling. And so what was nice about Cosmos or Tendermint is that there's an interface with the state machine that is very flexible and allows you to do interesting things that made it so that it was very compatible with what our goals were. And then I would say that the last thing is that the broader Cosmos ecosystem has a lot of support. There's block explorers, there's a ledger app, there's all these wallets, there's lots of staking providers are very familiar with Tendermint. So I think there's a kind of a network effect around the Cosmos stack that was very useful and made it, before Celestia, I co-founded a project called Harmony, and we built our own blockchain. We had to build everything from scratch. And it's so much more of a lift. You have to build your own block explorer and your own wallet and your own, all these other auxiliary things from scratch. And I think in Cosmos, it's really nice when you can just inherit that and onboard to a pre-existing ecosystem. In the future, we might, change the consensus protocol, but yeah. I'm going to hear from Sam.
Do you believe that a chain that just has DA and consensus like Celestia can achieve financial sustainability on the long term, since we know how to scale these DA resources in the future? I mean, there's a way to get much better results on that front. What would you think about that?
Yeah, I remember having long debates with this guy, Paul Initia, on Twitter. I don't know if anyone remembers that guy, but about the sustainability of data availability as a protocol. And essentially, so I don't know what your question is. Is your question, will a DA layer be economically sustainable, or?
The idea is that we can scale DA resources in the future. Let's say in 5 years, we'll have much more to offer. And what would be the agenda for Celestia to ensure that it remains financially sustainable? Maybe adding an execution environment. What would be basically the path for Celestia to ensure that?
Yeah, so I think maybe built into that is an assumption that as the supply increases, the cost has to come down. I think there's a few things. One is data availability. A better way to think about it is block space, basically. Block space is not a commodity. It very much there's a lot of factors that go into meaning that, like, Celestia's block space will not be the same as, like, if someone just like started a Celestia fork that they ran on their laptop, right? And so this notion that, like, oh, well, all block space is just going to be price each other out is, like, I don't think will be the case in the long term. However, Celestia's goal is to sort of like provide block space at a price point that is very reasonable and stable over time. And then the idea is that as the protocol scales, we sell more of it. So it's sort of like, you can think about it this way. Like, let's instead of saying like block space is like chocolate bars, right? And it's like Ethereum or I don't know, some other layer one is providing chocolate bars, but they have like this much. Maybe they only manufacture 100, right? Every 10 seconds. It's like 100 chocolate bars per 10 seconds. The demand is like 1,000. So instead they jack up the price by a factor of 10 and just sell only those things. That's kind of, I would feel like, what Ethereum is doing, or has been doing with their block space, is like it's artificially scarce, in a sense. And they're kind of constrained, it's not their fault. I wouldn't say that they intended to go that route. But Celestia's goal is instead to keep the price per chocolate bar at $1, but and when there's demand for 1,000 of it, have 1,000 chocolate bars to sort of sell to people. And then as the demand for block space keeps growing exponentially with the exponential growth of Web3, you now, instead of selling 1,000 chocolate bars, you're selling, 1 billion. You know what I mean? And I think that's kind of, Celestia is sort of a bet on the growth of the demand of block space. And like as long as you're selling it, it's the same with chocolate bars. As long as you're selling the good at a price that is higher than the cost it was to create, then you are sustainable and profitable as a protocol. So as long as the price per megabyte is actually at a level where it's costs less to make it, you're fine.
Thank you, Nick.
I don't know how much more time we have.
Yeah.
One more question, maybe?
One more question?
Recently, Celestia blockchain regulatory functions, Coinbase layer 2 base. In this case, we want to make TIA token be used in more modular ecosystem. So what is the usage of the TIA token when they use as a validating piece?
What was I got the first part about it, which is logic block stream on base, but what was the last part?
What is the usage of the TIA token on the base?
Oh, okay, good question. So that announcement, so maybe some context. So that announcement was that Blockstream is being deployed on Base, which is, as you said, like the Coinbase L2. And what Blockstream is a data availability bridge. So basically, what it enables is once Blockstream is deployed on Base, people can launch L2s on top of Base that settle to Base, but use Celestia for data availability. So that deployment of Blockstream does not have to do with TIA being on Base, but it has to do with people wanting to build rollups on top of Base, and they will use Celestia and TIA to pay for data availability. So that's what that's about. And again, it's really what's so cool about this is that people may have noticed that Base was undergoing this pretty significant congestion earlier this week because there's just so many users and so many applications. And so I think there's a demand for people to actually, rather than running their app directly on Base, they want to launch their own L2 for their app. And that way they don't have to worry about Base getting congested. So now people can launch their app as an L3 on Base and use Celestia for DA, have really cheap fees, and it's like you're able to, this is what I was saying earlier, Celestia enables you to scale in the ecosystem. because you're basically still building within the base ecosystem, but you're not so limited to basis fundamental scalability constraints.
Thanks again to the audience for asking great questions, and also thanks to Nick for sharing his thoughts. So yeah, great to have you here.
Yeah.
Definitely enjoyed it.
Thanks, guys. There's a modular meetup later today too, which I'll be at, so maybe see you guys there. Thanks for having me.
Thank you once again, Bernie. And before we move on, we also have more seats in front, so it'd be great if you can come over and sit here. And also since we have our networking time for later, so please save your networking activities for later. So our next speech will be discussing ZKPs versus FHE for privacy. And this is Kyle Kusiyama from Phoenix. Please welcome Kyle.
Hello. Hey, so I'm Kyle from the DevRel from Phoenix. We're at FHE L2. And so I'm here to talk about like kind of the post-ZK endgame using FHE for privacy versus kind of like the sort of the mainstream narrative of like using ZKPs for privacy. But yeah, let's get started. Okay, so real quickly, what is FHE, right? It's kind of a new term, I suppose. So FHE is short for fully homomorphic encryption, which put shortly is basically the ability to run an operation over ciphertext without decrypting. And so here's kind of like a quick example sort of how it can be used in practice. Essentially, if you want to run some sort of analysis on data, but you don't want to actually have to leak this data, basically you don't want anybody to actually know what the information is. So if you're sending it to a server and you want the server to run arbitrary functions on this data, it can actually run these operations on this data without actually having to ever know what the data itself is. And then even the output itself would be encrypted as well. So yeah, it's kind of like a high-level overview of FHE 101. And when I think of like FHE as new ZK, I think of it more as like FHE is sort of where like ZKP was back in like 2020-ish, maybe like 3 or 4 years ago. Where there's sort of like, yeah, it's kind of a proof of concept. People are still skeptical. A lot of people haven't heard of the term yet. People will say like, oh, that'll never work or something. But sometimes, especially in this space, things tend to move a little bit faster than we expect. It's hard to predict. But just going over kind of a quick timeline of what is FHE. So privacy homomorphisms, and you can kind of think of like homomorphism as sort of like you do something in one field, it should happen to the other. And basically using this for privacy is like kind of what you do in a plain text field should have a direct correlation with what happens in the encrypted field. And as you can see here, privacy homomorphism is like as a concept has existed probably since like the 1970s, kind of broke into the mainstream here. Some seminal work in like 1978. And for about 30 years, like I would say that there wasn't like a huge amount of like changes, I guess, from like the perspective of general homomorphism versus partial homomorphisms, etc. But the big breakthrough was right here in 2009 by this guy, Craig Gentry, who essentially came up with a concept called bootstrapping. So FHE within itself kind of uses this thing called noisy encryption. So you kind of think about it like if you're playing a game of poker, if you're always just playing it straight, people are going to know that you've got a monster hand when you put in a good bet, right? So sometimes you got to bluff, sometimes you got to throw in some noise, you got to throw in some lies with the truth. So that's kind of like the basis of what you can consider like noisy encryption. But the issue with this is if you're doing multiple operations over and over and over again, the noise that's needed to basically hide the truth is going to compound, in this case exponentially. And so in this case, Craig Gentry basically figured out a way for, like I said, bootstrapping, which you can kind of think of like keeping the amount of noise constant, sort of like a reset period. And I won't go into like every specific detail here, but essentially there are a bunch of different branches in terms of like schemes of fully homomorphic encryption schemes, I suppose. For example, some are speculated to be better for certain aspects like machine learning, certain operations, but at Phoenix we are currently using this branch, the fast bootstrapping branch, this library maintained by Zana, which is an FHE research firm. which is using TFHE, which is Torus fully homomorphic encryption. But like I said, in general, our operating system is pretty modular, so at the end of the day, if it turns out that we need to use some of these other schemes for like a specific operation, we can switch that out in the future. But like breaking it down, FHE versus ZKP, like I said, I'm sure most of us are familiar with the concept of using ZKPs for privacy. However, there are limitations to where shared state can actually be managed. So right when you're not just doing it sort of on the client side or whatever nomenclature you prefer, when it has to be multiple parties using multiple things, kind of like a, like an AMM, for example, right? Like many people are going to have to remove liquidity, add liquidity, swap. It's going to take multiple parties. And so ZK proofs kind of tackle this challenge by keeping only the committed data of the proof and the correct computation on chain, which, as you can see, that does have some issues because you cannot run an operation without decrypting, right? So the plain text eventually has to be known, which means the plain text copy of it is kept somewhere. And then this input sort of work for certain use cases if you're using like single party, if only a single party is required, but in the essence of making these like large blockchain applications in general, usually these are going to require like multiple people actually entering a network, which is kind of the crux of blockchain technology if you really think about it. So as you can see, as like a quick comparison, FHE and ZK can both be used for privacy technically. Right now, ZK is more scalable than FHE, but I mean FHE is scaling very quickly, in my opinion. Like anecdotally, even something as like a ciphertext over ciphertext division was kind of considered like computationally infeasible to do in the scope of like blockchains, I suppose. Even as recently as like early 2024. But because FHE supports general operations and you don't need to decrypt at any point, basically this offers you a level of composability that is kind of unrivaled in ZKB. And fundamentally, at the end of the day, these are operations that are done on chain and can be verified. Like for example, one of our current implementation is an L2, like a rollup essentially. So basically, all these operations can be verified on chain. So this is kind of a quick rundown. But I also like to think of it as like ZK and FHE are kind of solving two fundamentally different problems here. Right, like at least specifically in terms of privacy, like ZK is kind of trying to solve the verification of like off-chain execution, trying to like be able to simply verify. While FHE is trying to solve the challenge of like on-chain privacy itself. And I think that there's a lot of like space that these two technologies can overlap. And just to kind of summarize some of the issues that I've been saying with ZKB for privacy, and I'm just speaking generally here. Obviously, there's always like a way that like anything can be done with enough bells and whistles, I suppose. But generally speaking, it's difficult or almost impossible to compute over a shared state, which if you think about it, you're generating the proof on the client side, you're submitting that, like how can you verify that like there's something could be adversarial, you could cheat before the proof is actually, the proof itself, and sure you can verify that that was done correctly once it's kind of committed, but what happens, before that, the off-chain part, so sort of like the off-chain aspect of it, so the prover would know this information. And again, if you take nothing else from this presentation, basically just it's like at the end of the day that the main lacking aspect here is the ability to run an operation over a encrypted field without decrypting. But there are benefits, of course, to ZKP for privacy over FHE. I think the one that stands out for me is ZKs basically allow you to verify this computation succinctly. And so that aspect, I think that it theoretically could be used to help scale. As can be used to help scale a lot of things such as blockchain in general. I think it can also be used to scale FHE operations. And when it comes to state construction, again, ZK kind of is constructing this off-chain, while FHE is really doing it on-chain. And so while FHE allows us to update without decrypting, that allows us to avoid leaking plain text to memory. And leaking plain text to memory is sort of like the cardinal sin of leaking and forgetting hacked, or like having some sort of vulnerability, especially in like the blockchain space where everything is on chain, all these state transistors on chain. If it happened at some point, there's going to be some sort of tracing in the stack. So FHE does do these operations one at a time, which is arguably more in line with the general state transition ethos of blockchain. And so maybe for those of you that are more like visual learners, I like to think of it as like ZK is sort of like a picture specifically, whereas FHE is kind of like a movie, or like a bunch of still frames kind of put together and sort of kind of create like a moving image basically. And with FHE, since we're allowed to act this private state is actually composable, we can theoretically add another frame of the bird doing whatever. If we want to go to like frame 3, for example, or like, hey, that doesn't look right? Maybe we need to like fix one of the positions of the bird or where like the seed is, right? You can actually change it, move it up or down. And so that level of composability is sort of like one of the key distinctions when it comes to FHE versus ZK for privacy. And yeah, so FHE is pretty good for multi-party compute in general. They're like, as you can see here, usually in the ZK system, if you want to create something like this, the private states would kind of have to go be submitted to the validator, and then the public state can be constructed from there, because again, you cannot construct the state without decrypting. If you're decrypting, then kind of what's the point, right? Where it's sort of circular, like where did this get us in terms of like actual privacy technology? But with FHE, each of the users themselves can actually interact with the validator to submit the operations that they want, and from there you can have a trusted on-chain state. Like I said before, like kind of the AMM example, like you can actually interact with the exchange itself while passing in ciphertext, and some would argue that this is actually a solution to like MEV in general. Anyways, I kind of digress. So what are the alternative FHE plus ZK methods? I kind of talked how these could be used in conjunction. And so this is just kind of a project that was submitted to us a couple weeks ago in London. Basically, if you want to check it out, here's the QR code. But it's from a high level, allows you to circumvent the pairing function while encrypting the result of the actual proof. So whether or not, okay, hey, this proof was valid, this proof was not valid, you can actually keep that on state as an encrypted boolean, which actually could theoretically be used for this to construct more of a state. But anyways, I digress. So you can take the result of the proof without leaking, like I said. However, the issue here is that it does sacrifice distinctness because these operations need to be done by hand. And so from a high level, I'm not going to go too much into going over like the anatomy of a snark in this situation, but basically for this specific example, just think about it that the verifier part is the part that's being done in FHE, this pairing test, the yay or nay. And so obviously the whole process can really be done traditionally through FHE because there's a very expensive function and multiplications, divisions, especially a loop of them would just overflow the blocks, so this would never happen. And like I said, like we are sacrificing succinctness here, basically to replay a computation in FHE. And so that is kind of the sacrifice. And if we were to go the other way, here's another example where this, instead of being done in conjunction on the verifier side, however, it can be done on the prover side. Again, here's another example if you guys want to check it out. But from a high level, this is basically using like a guess but just for the sake of reference. But basically, the host, the user would basically create a public and a secret key, encrypt two numbers of ciphertext with the secret key, pass the pub key with the two encrypted numbers to the VM itself. The VM would fetch the encrypted data, initialize the FHE framework, perform the actual operation. I mean, let's keep it simple, just add two numbers or something, and then send back the encrypted sum to the host. And then now that the host has this encrypted sum, they're able to decrypt the sum with their secret key if they actually want to see the value. And yeah, so I kind of just wanted to sort of wrap up the presentation with kind of like sort of an anecdote about how I specifically got into FHE. So I used to work in like on-chain gaming, and I realized that I wanted to make an on-chain game engine. And from a high level, I realized that I needed to have asynchronous inputs that from different users that could advance the state synchronously. And so that's basically just a fancy way of saying I was trying to make like an on-chain version of rock, paper, scissors. Because my logic was like, sure, if you could create a version of rock, paper, scissors where someone puts rock and we're playing for money, right? If it's not encrypted, I'm just going to query that answer and I'm going to basically just backrobe them and be like, okay, hey, I'm obviously going to go paper. And so this can be extrapolated in a more advanced like type of engines, such as like Pokemon. I don't know if you guys are familiar with Pokemon, but in Pokemon there are some interactions when you're playing this game where both players need to pick their move asynchronously to advance the state synchronously, where there are conflictions, such as things like protect, fly, dive, focus punch, etc. Sucker punch. There's a lot of different examples where the input of another user is going to impact the way that the state branches. And so initially I was like, okay, well, I was taught that like ZK for privacy is the main narrative that's being taught by the Ethereum Foundation, the PSC, etc. So I went to go talk to them, and basically they just gave me an example of using a commit reveal scheme, and I was like, well, if we can use a commit reveal scheme, why even use ZK in this aspect? So kind of like that is sort of the route that we were going down. And so how would this process actually work? So here's kind of an example that was submitted to us in Denver, but you can basically just think about this as like another more advanced version of like rock, paper, scissors, basically, where someone is basically just committing their move. In this case, it's like an army move, right? Like defend high, defend low, and if the attacker chooses the right place to attack, then they're allowed to loot the city, etc. So as you can see here, basically only like the hash is saved on chain, but something such as like the nonce or the pre-image or some sort of like password, basically the key, would have to be used to verify that the user here, player one, actually did pick rock or they picked to defend high, etc. And then that would be used to confirm later. And then step two, the player is just going to make a public attack here because obviously they're going second. It doesn't really matter if the other player knows what their attack is because the first player's already committed their move. And so again, the hash is saved on chain. And now the third player actually has to go in and use their original like nonce value essentially to verify the proof that this is what we actually did, going through the process, and from there, the second player can actually make this decision now that they know, what this public attack is, what they want to do. And with FHE, this is actually becomes only 2 steps. And in terms of like the user experience, the client or the first player themselves doesn't have to keep track of the actual like nonce value essentially. So the first player basically is just going to pick their move, right? So in this case, to keep it simple, like in a rock paper scissors example, if 0 is supposed to map to rock, you just put an encrypted integer value for 0, and then from there, the second player just has to make their attack. And since we can calculate what happens, since we can actually store the on-chain, the encrypted value on-chain, use that for a computation, the result can just be applied directly in this 2-step process. And so this is kind of just like an example of like how you can use FHE, to create like on-chain privacy for like a bunch of different aspects. And at least at Phoenix, like our library, our stack is relatively easy to pick up if you're familiar with Solidity. It's basically just import. We support like native EVM opcodes plus like a little extra stuff. So it kind of works on privacy how you think it should work, at least in my head, where it's like, hey, if I can keep this integer encrypted, like just directly on the smart contract, where instead of being queryable, it's just an arbitrary hash of like ciphertext, bytecode, etc. And from there, if you can have encrypted integers, you can kind of create like encrypted states through mappings, etc. But yeah, so that was pretty much the presentation. If you want to contact me specifically, you can hit me up. I can do my Telegram. Also, you can feel free to join the Discord. You can get routed to whoever on the team would be relevant to talk to. Feel free to check us out. And yeah, I just want to thank you for your time, and I appreciate it.
If you have any questions, please feel free to ask Kyle.
So thanks for 2 questions. One is I was curious about performance / benchmarks. Like if you encrypt, basically you're running computational or encrypted ciphertext, right? So like regarding the size ratio between the plain text and ciphertext, and how much difference is there between running just raw computation over plain text and computation over ciphertext? Like I have plenty of friends who are working in CKKS regime, like my friends are in crypto lab, for example, and I talked about the recent Zama's funding, and they're not from blockchain, so like there's limitations to both of us because I lack knowledge in TFHE and they lack knowledge in blockchain space in general. So there's limitations in our understanding, but our initial reaction was like, isn't this way too heavy for something that no one can handle? So like, which is why I'm asking about benchmarks. So that's number one. And number two is another question. How different regarding performance is TFHE and CKKS, if you don't know?
Yeah, that's a good question. And shout out CKKS. I didn't realize that was kind of the created in Korea. That's interesting. So your original question was through the throughput. Yeah, so like I said, we are in L2, and our stack right now is for basically fork the Nitro 4 prover. Essentially, kind of for performance. So if you want to look at like core benchmark stuff, you can look at that. However, like the other aspect of it was kind of like their WASM execution, that they use for Stylus, because basically that allows us to run the operations themselves in Rust and import the precompiles, and then have those operations themselves be compiled to like some sort of WASM format that the actual prover can like verify on chain, I suppose. But in terms of computation, it is pretty nuanced. Like obviously it's going to be much slower. Some would say like it's order of magnitude slower, than doing something over plain text. specifically, you know, there are nuances to it. For example, like certain operations are more expensive. Like obviously, division is going to be more expensive than like an addition. There are kind of some bottlenecks, such as like encryption. Also, is kind of a big bottleneck too, right? Because like then you actually have to hit the network. You have to get the event approval from the threshold service network, essentially, and then that has to come back. The short answer is like yes, it's much slower, much slower. The specific calculation or like I guess conversion over like how much slower versus plain text versus ciphertext is very dependent on the operation and the bit size itself. So for example, like 8-bit encrypted 8-bit is going to be a lot faster than like 32. But yeah, and your other part of that question was the YTFHE versus CKKS, I think is. Yeah, so there are some like research that's been done into using like the BGP CKKS branch of like proximate schemes. My understanding, and again, I'm no cryptographer, I think is that why like Zama specifically, I think you referenced, is using the TFHE for blockchain. I think it's because it is, you know, it's exact, so I think it helps with the deterministic nature of like the blockchain's kind of neat. But as it pertains to, I guess, something more domain specific, maybe like machine learning, that is a good question. I don't have a great answer. My understanding is that I think Zama is currently choosing to go the TFHE route because TFHE is the only, or I guess is the most advanced, like, modern FHE scheme that has programmable bootstrapping. And like the lookup tables, I think you don't get with CKKS because of, again, the approximate nature. Sorry, what's your second question?
That was my second question.
Okay, great. Yeah, great question, man. Yeah.
Yeah, if there's no more questions, then thank you again for the amazing speech, Kyle, and we'll have our next speech. 다음 스피커분 모시기 전에 홍보를 안내 한 번만 드릴게요. 저희 앞에도 좌석 굉장히 많아서 이쪽에 와서 앉아주셔도 되고요. 그리고 네트워킹 시간 저희가 따로 마련해 놨으니까 발표 도중이 아니라 네트워킹은 네트워킹 시간을 활용해 주시면 또 감사하겠습니다. So up next we'll have Jessie from Initia, and she'll be discussing
the future rules.
Yeah, thank you. Please welcome Jessie.
Yeah, Jessie.
All right, hello everyone. My name is Jessie, and I proudly represent Initia as a DevRel. Today I'll be presenting on the future of rollups and especially on the problems with rollups in the current market and how Initia fixes it. So before I start, a little bit about myself. I joined the Initia team just about a month ago, right after doing one coffee chat with the team. And they showed me the products they were working on, and they had amazing devs, very tech-driven, and they were all really passionate about improving the blockchain space, so I immediately joined. So I work as a developer relations engineer. So what I do is I contribute to helping devs outside of Initia to onboard onto the ecosystem. So I started doing this by rewriting our dev docs for our builder and validators. And I try to do more sessions like this presentation today in the future. So, and in college, I majored art history and computer science, and prior to Initia, I was a blockchain researcher and developer. So all my career combined, my interest lies in seamless user experience and technology in blockchain. So enough about me, and let's get started. I'm gonna start with how the current blockchain industry has evolved and gauge the trend going on based on some new project that has emerged. We know that there is Ethereum and there's Cosmos. And then the Cosmos chains are continuously growing. And the ETH rollups are fixing Ethereum's scalability problem. And there's other blockchains too, growing their ecosystem with niche approach to solving blockchain problems like scalability. But these worlds of blockchain are very fragmented and isolated. Each world, they work as different countries. So they have different set of rules, different cultures, and they're not interoperable. So to fill in this gap, there are some new projects that try to fill in the interoperable problem of this multi-chain world. So like projects like Polymer Labs, or even some projects that'll be presenting later on today, like Avail will be presenting on solving role fragmentation, and Axelar will be presenting on cross-chain interoperability. So they're trying to fill in this gap between the fragmented world of multi-chain. So through these trends, we can tell that the problem of fragmentation in blockchain has been noticed, and there are emerging demands among users to hop between different blockchains. But we as end users all know that the multi-chain experience is shitty. But we're all gaslighted somehow. We think that we believe this is a necessary experience. So, the problems we encounter. Let's examine a hypothetical scenario where I've tried to buy an NFT on Stargaze. Since I don't have many stars to buy a bad kid, I would go onto Osmosis and with my assets. So I would swap my assets into stars. So in this case, Initia. And then I will have to pay the gas fee in Osmo, which I luckily had in this case. And then I'll still have to go onto the assets and withdraw my swap stars from Osmosis to Stargaze. And then finally, and then I pay the gas again with Osmo. And then finally I can go on to Stargaze and buy a bad kit, but I still didn't have enough stars, so I couldn't buy one. So as a developer's point of view, Cosmos is a really great framework because it really lowered the hurdles of developing and deploying customizable blockchains. However, as a result, there are hundreds of different blockchains on the ecosystem that are not really interconnected. Also, each Cosmos chain is its own L1 with requirements with validator sets, native tokens to pay for security, the inflation of said token, and tons of peripheral infrastructure. So now the other option, for ETH rollups, it's really easy to deploy, but there's not much you can do but to change the gas fees. Ethereum rollups are also not interoperable with other blockchains and often enforce the use of EVM. And while plenty of amazing teams have been building systems to connect these networks, there's still plenty of third-party services needed, like oracles and bridges. And also the bridge gas fee is crazy. So how should the rollup frameworks look like? It should be fully customizable. Developers should be able to build whatever they want on a blockchain. It should have access to security. Even for small starting chains, they should be able to gain validators easily. And last, it should be interoperable. What I mean by this is that the users should be able to hop back and forth from one blockchain to another easily. Here's where Initia steps in. Initia was designed after the fundamental concern that fixing any problem after we encounter is not working anymore. So we rebuilt the entire system. So imagine like when using an iPhone and its app store, as users, we don't really know or we don't care how the app was made if the developers used React Native or Swift. We just use it if it was well made, right? Also, the users experiences cohesive UX when using multiple different different apps across the App Store. But we're able to use similar interactions such as Face ID for security or in-app payment through the App Store. Well, same goes for Initia. We're trying to enhance the shitty user experience of the blockchain into that of an iPhone. So developers can use whatever environment, whether it's EVM, MoveVM, or WasmVM, and deploy as a Initia on Initia. And users on Initia won't have to know the developer's preferences, but just use the chain and experience a cohesive interaction as if they were one chain. And the idea behind such chain abstraction is quite simple. Technology should be abstracted away from the user. In other words, people don't have to realize which blockchain they're using. This is why we call Initia a network for interwoven rollups. The rollups on Initia will be interconnected through Initia Layer 1, so that developers don't need extra steps for onboarding and users don't have to worry about handling n amount of tokens or chains while using the rollups. So for introduction, I'd like to start with the whole architecture of Initia. We call this entirety the Omnitia, including all the ecosystems on Initia and the Layer 1 Initia. The Initia Layer 1 is an orchestration layer that is used to coordinate security, liquidity, routing, and interoperability throughout the network of all rollups on Initia. The OP-Init stack, which I believe is the first optimistic rollup on Cosmos, enables the rollups in EVM, MoveVM, or WasmVM to securely scale while utilizing the Celestia DA layer underneath. Initia provides universal consistency, where we provide one chain experience across all chains deployed on Initia. This means that users won't have to worry about handling n amount of chains or n amount of tokens to use various chains on Initia. So, for example, we have the just-in-time gas. Remember when we had to have enough gas ready in our wallets in order to use new chains? With Initia's just-in-time gas, you won't have to worry about that anymore. So let's say you're trying to buy an NFT on a marketplace on Initia. And even if you don't have gas in that token, the wallet UI will suggest, oh, you have this amount of USDC in your wallet. Would you pay with that instead? And as you sign, the backend of the system will swap through the initial layer 1 and transfer your token to that marketplace. So as a user, you won't need to worry about handling many tokens to use different chains.
Good feature.
Yeah. And how we do this? We do this through enshrined liquidity held within the Omnitia Liquidity Hub. So enshrined liquidity is a mechanism by which solo init or init and token pairs are staked directly with our validators to build a hub of liquidity directly into the L1 chain. Enshrined liquidity is used to bolster security and amplify liquidity and act as an inter-L2 router to send one token from this blockchain to another. Secondly, Initia ensures full customization of blockchain development on Initia, along with guided sovereignty from the orchestration layer 1. Initias allow developers to choose from any VMs, EVM, WasmVM, or MoveVM. And the OP-Init stack, complete with fraud proofs and rollbacks, enables Cosmos SDK-based rollups in all VMs to securely scale, and while utilizing the Celestia DA underneath. Also, every interwoven rollup has access to native USDC, CCTP, multiple gas feed knobs, dev tooling, oracles, and bridging, DAO toolings, scanners, EVM, Cosmos, wallet signing, and many more from day one. Last but not least, Initia provides robust security through the Omnitia shared validator sets. Initia utilizes the Celestia DA in order to remove the burden of downloading the entire blocks for the execution and settlement layers. So, this is a diagram of how Initias are connected to L1 through the OP-Init bridge and IBCV layers. The Initias send transaction data blocks or call data to the Celestia DA. And when a fraud is detected, the relayers will shut down the IBC and request for fraud-proof challenge. And Initia's L1 validator set, which integrates Celestia Light nodes, will verify the data using Celestia's NMT design to only download appropriate transactions. With such design, validators can fraud-proof without needing to download the entire blocks. So now that we have gone over the pain points we encounter and how Initia solves them, and the technological design behind Initia, I would like to introduce the softer parts of Initia and how we provide better experience to our community. So we try to lower the barrier of complicated UX in the blockchain industry, so we try to show that with our UI. So first up, we have the Initia wallet. You can use this from day one, and where you can sign in with many variations of your preferred social accounts using Web3. Oh, this is the main Initia app that the user can use from day one. And you know how blockchain UI and UX can be really intimidating? Like, for example, when you use a Binance app, when you enter the expert zone or whatsoever, it kind of warns you how complicated it will be. And then when you enter the expert zone, the UI just intimidates you. So we try to eliminate that through our UI. So we use conversational titles for our what you're gonna do on this page, and the user will be having only one action per page for a less complicated experience. So you can stake Init and Init pair tokens directly to our validators in this app. You can also swap your assets. You can create pools, and you can check proposals and vote and create proposals using the Init token. And then there's another interesting app we made is the Initia usernames. So it's like DNS. I claimed win it to Init, so Init to win it. Get it? Anyways, I claimed that to make sure you claim your unique names when we launch. So finally, I want to introduce the vested interest program, which is used to align the interests of all parties within the Initia ecosystem. So the users, developers, L2s, and the L1. We call this VIP in short. Basically, the VIP will parameterize the distribution of init inflation directly to users of L2DX. This economic activity will directly accrue value to Initia. Application and developers will be incentivized to integrate init and be long-term aligned, and allow teams to amplify user engagement and reduce the cost of acquiring and retaining users. So, most importantly, when testnet, Initia is currently working on our private internal testnet, and the public testnet will be out in the very, very near future. So I'm working on our developer docs to help build on Initia, so please stay tuned. And while you wait, please follow us on Twitter, both at InitiaFD and 0xjesse_ for me for updates and announcements. Well, thank you for having me today. You guys were awesome. Please come talk to me or my teammates in the back if you have any questions. We're all wearing this Initia t-shirt. We have brought this cool merch with us today, so please help us out. And please enjoy the rest of the event. Thank you.
If you have questions,
Please come talk to me.
okay. So thank you again for amazing speech, Jesse. And up next, we'll have Honorable Arjun from Avail, and he'll be discussing
Hello.
Yeah, please welcome him.
back in 2017. And Avail was actually a project that we started within Polygon back in 2020 and spun out of Polygon in March 2023 last year. And so I'm going to be talking today regarding the Avail solution, what it is, but also what problems does it solve. And happy to answer questions between the session, after the session, anytime you want. I will also be around here for a while. And this is my first time in Seoul, South Korea, and I'm really loving the city. It's a very nice city, very walkable, and with very nice food. So very happy to be here. Okay. So before getting into the actual roll-up fragmentation issue, I just want to kind of start with just set up some background in terms of where are we in the current blockchain scenario. It started from the Ethereum world back in 2020, but even before that, most guys don't remember. I've been here like 7 years in crypto. We started off with building something called Plasma. Plasma was one of the first off-chain scaling solutions on Ethereum. That didn't work out, but rollups are these very special innovations that essentially allow you to spin up chains pretty quickly. Before rollups came into the picture, what you had to do to spin up a chain was to kind of recruit a validator set, introduce a new token, ensure you have the token is valuable, create a community, and so on. So it was very expensive to spin up a chain. Rollups really, what they bring to the table is that they just make it very easy to spin up chains. So if you looked in the Ethereum ecosystem, so if optimism was there, but Base just came up, took the OP stack and just spun up a chain, and they don't have to focus too much on spinning up the chain, but they have to focus more on the business side, on the application logic, on how to grow the ecosystem. So rollups are that point in blockchain future where developers don't have to spend too much time on the infrastructure side. They can focus more on the application side. So, and we expect that rollups are the best bet to scale blockchains. And in that respect, what they really require is something called data availability or scalable data availability. And so that's really the first problem that Avail solves in general. This is what we call the Avail Trinity. It is comprised of the Avail DA, Avail Nexus, Avail Fusion, and I'll get to what all of this do. But let me scroll back a few slides saying rollups are the best bet to scale blockchains, but they are very hungry for DA. Yeah. Once we've you must have heard of data availability layers Avail is upcoming one, you must have heard of Celestia, and so on, right? So these are chains that basically scale rollups. But once we've enabled that, already there are 100 odd rollups already live, and we are expecting probably 500 or 1,000 this year, and tens of thousands more. Now, what then happens is that there is a proliferation of rollups, and that kind of fragments the user experience. And so, you really need this kind of rollup interoperability framework or unification framework, as we call it, to ensure that all of these rollups work in tandem. So that's really the overall problem that we solve. And this is some big picture story in the sense that we believe that there are going to be these hundreds of rollups that we will end up enabling, but we also have to address the growing rollup fragmentation problem. And this is sort of those coming from Cosmos. This is basically an embodiment of the Cosmos ethos coming to Ethereum, in the sense that Cosmos envisioned the app chain thesis, that in the sense that there will be a lot of app chains, And that story is now playing out on Ethereum, where there is a lot of rollups taking that place, for example. So going back to the Avail suite of products, it's like there is Avail DA component, Nexus component, Fusion component. What is Avail DA really? It is this scalable data availability layer that enables rollups to scale massively. We implement this using something called KZG polynomial commitments and data availability sampling. These are some of the primitives that Ethereum is going to use on its dime sharding roadmap. When we started in 2020, we knew it was going to take time. Ethereum just launched something called 4844 or proto dime sharding. But that's just the first step. The dime sharding roadmap is going to take a little time, and rollups don't really have the time to wait for that upgrade. And so Avail DA is in my, as far as I know, the only project that implements data availability sampling with validity proofs. Celestia does it, but it uses a implementation of optimistic or fraud proof based technology. We use a validity proof based approach. And we've been building this for the last 3.5 years, and mainnet is soon, in a few weeks. This is a little bit more detail into the architecture, how it handles transaction data on a per app rollup basis. We have the concept of application IDs for each rollup, and so you don't have, our design is slightly different. We don't have different blocks for different rollups. Everything goes into the same block, and then you can run a light line that specifies a particular application ID, so that they will just query their own transaction data. Avail DA is primarily infrastructure for rollups, right? And it has, we use the substrate as the basic, as a base for the validator node, and therefore we have this hybrid ledger consensus called grandma and babe. And so we are able to kind of support up to 1,000 validators today, but an upgrade to that next year will bring that number more than 10K and above. And of course, I mean, any sort of rollup can be built on top of Avail DA. It could be EVM, but it could be app specific. We have rollups ranging from Cairo VM, RIS0 VM, Sustained VM, Wasm VMs, like all sorts of VMs are supported, and a lot of people are already building. Light lines is something this is like a lot of the cutting edge work that we have done over the last 3 years. This is a separate network that connects to the main Avail DA base layer and operates a P2P network between themselves. This uses validity proof, so in the sense there is no fraud proof challenge game. It's basically, you can think of this as kind of the difference between optimistic and ZK rollups as such. And you of course need to only download a very small fraction of the data to guarantee data availability. So Avail DA is already a very state-of-the-art solution that can scale rollups, but we go over and beyond that. What we know is that we will eventually be enabling hundreds and thousands of rollups. And so what we started work on last year was something called Avail Nexus. And so if we go the same path that we are going, what is going to happen is we are going to have these multitudes of rollups. And then once you have this, it's very difficult to kind of move things like funds or just pass messages between one rollup to another, right? It requires you to go to the Ethereum base layer, then back, for example. And so that's going to be a big problem. And building bridges between each rollup is also going to be a mess. And so because we already built this shared DA layer on which these rollups operate, it gives us a very special relationship in terms of building this interop infra, because the DA layer itself is shared, and so we can actually build out one unifying coordination layer on top of all these rollups. and that's really the Nexus part. It basically works on the principle of combining the data availability sampling validity proofs that we have, and we combine that with the execution validity proofs that rollups gives. So we do this massive proof verification and aggregation play, which kind of aggregates proofs across these rollups and then combines them with ordering proofs to kind of ensure that we have shared notions of validity, and essentially, like it involves Avail using Avail DA as a root of trust. In general, what it really means is when we do this proof aggregation build using Nexus, we do not need to know state transition functions because these proofs are already verified with the single proof that we provide, and we are able to, with the help of zero knowledge proof technology, ensure that the transitions were computed correctly. And so all of this is moving us to a more singularity proof or proof aggregation sort of play. This is sort of the overall high level picture of how Nexus fits into the entire architecture. The Avail Nexus layer itself is not a separate blockchain. It's actually a ZK coordination rollup on top of the Avail layer, and it does two things. It does a proof aggregation thing, and it does a sequence selection thing, and there's a bunch of mechanisms by which this works. The first version we are expecting for Avail Nexus testnet, we are expecting sometime later this year. So Avail DA is launching in a few weeks on mainnet. Nexus will launch towards the end of this year. And finally, and so that's really like the rollup, how we are kind of tackling the rollup fragmentation issue. But to top of that, right, like we also, to build this unification layer for the entirety of Web3 or for all rollups in general, you also need a high level of cryptoeconomic security, and so that's where Avail Fusion comes in. So we want Avail to be the Web3 coordination layer, and so we've built out something cool here in the sense that the Avail base layer starts off by relying on the native Avail token for staking, but we've been like taking inspiration from ideas such as Osmosis mesh security, for example, and eigenlayer restaking. What we also do is enable other tokens, other valuable tokens like BTC and ETH to be staked in the base layer, and so this kind of increases the cryptoeconomic security on the base layer. And so ensuring a unified security for the unified ecosystem. And that's the mainnet for that is probably sometime next year. Yeah, so quickly, trying to summarize, what we want to do is, like rollups we think are the future of blockchain scaling. We enable first a lot of bunch of rollups using Avail DA. We use Avail Nexus to solve the rollup fragmentation issue, and we do Avail Fusion to kind of unify the security so that the entire construction has a high level of cryptoeconomic security. So I'll just stop here, and these are some of the details. You can scan QR code for contact details, and I'm available for any questions. Please feel free to ask. Thank you. Any questions, or I'm here for some time. Thank you.
Thank you for the powerful speech, Anura. And from now we'll have networking time for about 30 minutes. So please enjoy the time, and I'll be right back in 30 minutes. Thank you. 네, 여러분, 저희 지금부터 30분 동안 네트워킹 시간 있어서 네트워킹 시간 자유롭게 가지시고 30분 후에 다시 뵙도록 하겠습니다.
Initia or which project are you for? Me? Yeah. I'm real media. What's the project? You guys are super busy. Super busy, super busy. There's so much happening. Go to sleep. Look at people like this coming here. Active every man. After work, go to sleep. Go to did you go to any side? Yeah. Absolutely. This is not big. Yeah. I mean, there's still, it's a wood. Big things yesterday. Very small. And because that, yeah, part of the machine. Focus on payments and increasing technology. And we have a brand new $25,000. So everyone will build on top of it using us. We also have a referral commission, $2,000. If, for example, any of your team members want to introduce us, potential guarantee, we give them a grant and $25,000 and we give $2,000 for every 25. So for each project we introduce, there is $2,000. Do you have any issues? I did tell you. Doesn't work. Sounds like that. I mean, there's always a start, right? So it's not important to get the plan. And also to the calculation. It's nice to meet you. Are you with the organizers here?
Actually, no.
Yes. Just recording.
Yeah, just recording. I am streaming.
Oh, nice.
Yeah, everybody can see.
That's amazing. What platform do you use for streaming?
Not just for just my hobby.
Which one?
Just for my hobby. Okay.
For yourself to study later on.
Yeah.
That's pretty cool. Do you have any friends that are coders or developers, founders?
Some of here in here.
Right here, some of them.
Yeah.
Because we represent, we have a grant program, $25,000 for founders and builders that are building like invoicing or payments or accounting solutions and everything. We are supporting them with this grant.
Oh, you can send me some kind of information.
We also have a grant, aside from the grant, a referral program. So if you introduce us somebody that you give them a grant, we give you $2,000 for introducing them to us. Maybe this can help us. What do you do in this place?
Just for fun or not. actually, I'm 지금 쉬고 있어요.
Learning, like researching.
Yeah, I'm kind of researching.
The crypto space is so big, there are so many things happening. So
Yeah.
it's also to look into. How do you pronounce your name?
I will talk to you. Heejin.
Because I don't know how to read backwards. So I will send you here more info about the brand program. And these are the use cases that we're looking for. Our links were presented. And also, I mentioned earlier $2,000 for initial for a project. Because there are people who are sending us more than one, so for each is $2,000. It's basically quite easy, right? And then you guys, you're building this, these guys, if you need funding. And then we know they are coming from you. That's important.
Yeah.
Otherwise, I wouldn't know who comes from who.
Yeah.
Yeah. So that's how we keep track per project. Yeah. Because like to me, I just came to Seoul like 3 days ago. I don't know anybody. So that's why we're trying to connect, expand. We have funds. We have a total already since 2016. So that's how we connect the brand and also the recognitions and the marketing, the travels and all that. So. What time did you start with?
Maybe.
So quite soon. Yeah, now it's the network essential guy. It was nice meeting you, man. I can keep in touch. I hope I'll give you a donation.
Yeah, I will.
Yeah, let's do it. Let's do it. Are you with Avail or not? Alex.
Oh, Alex.
Yeah, nice to meet you. Which team? Request Network. We are basically since around 2007.
Yeah, I know. I did. Same here.
It was very nice to talk. Yeah, I just have I like the person. And I am happy to hear that in a few weeks data coming out. Yeah. I was looking at the. Yeah, sure. I was looking at the Facebook activities and all that. That you guys said, but so I don't know if you can support me with this.
So I don't have much idea to be honest about this.
No, right?
But what are your questions?
Because I accumulated some AVL, it's testnet, right? And I would like to try to test it, like staking or like do something with it. And I cannot do anything with it. I just collect it. So I'm just trying to use this, the activities more. So either you or he will be able to tell me more about it, or
I am not aware, but he will be super busy then. But who are the guys there on the spot?
Yeah, I mean I asked around, but nothing much.
Is there someone named Rishi?
It's okay, I'll figure it out. But I'm excited about the project and I really like the Trinity concept. I think it's so exciting that others who cannot consider.
Yes,
It's a competitive advantage right. So hopefully things will go.
Thank you.
Mainland is like free next year. Actually, maybe or Wednesday will come next year or this year.
So Fusion will come with Nexus. D is coming as it was.
Yeah, in a few weeks. But that will come maybe will be launched next week or That's what I don't understand.
What do you mean by heavier?
Yeah, token by soon. So and the rest of the features is the
Yes. Nexus by the year end.
and Fusion next time. And let's see how.
So I'm not much aware
Don't
about
worry.
the.
Each company with their own departments.
Yes.
I know how it works.
Hey Tommy, man.
Hey, good to see you in person.
You live in Korea?
No, I'm based in Hong Kong.
Based in Hong Kong?
Yeah, I just landed yesterday here.
Oh wow. How was the event?
This
Is there any coffee I want to make?
Yeah, sure, let's go.
점점 없어지는 단계예요.
Yeah, so I haven't received.
저희 따로
이거 곧 아발란스 나오거든. 아발란스에 엠베스가 그 개인적으로 지금 6명 지금 2차로 바로 그런 걸 저기 하고 있어요.
아 이거 최본 자리인데 이거 최본 자리인데 최본이 안 오셔. 아 그래? 최본 안 오셔.
그 뭐야? 아 이거를 누구 거예요?
몰라요. 그러니까 이게 안
누군 거 같은데? 아까
아니 스타팅에서 감춘해가지고 안 먹고 갔는데 밥을
먹고 맞던데.
진짜 제가 오긴 얼마 안 됐는데 엄청 많이 했죠. 마음속에 시간을 정말 정한 게 있어요. 근데 지금 그 시기에 이런 걸 하는 게 뭐야 영향을 줄 거니까 그래서 이제 전에 이니시가 주체잖아요. 그래서 이번 주식에 이런 음악을 만들어서 이 정도는 된다.
We're about to start our next section, so please be seated, guys. Please be seated. 네, 여러분 저희 3시부터 스피치 다시 시작할 예정이라서요. 즐거운 시간 보내시고 계시겠지만 다들 참석해 주시면 감사하겠습니다. 여기 앞에도 자리 많으니까 앞쪽으로 참석 부탁드릴게요. So guys, please be seated. 여러분 저희 곧 세션 시작하니까 참석 부탁드릴게요. 여기 앞에도 자리 많으니까 여기 편하게 앉아주시면 됩니다. So we have seats in front too, so maybe you could sit here. So the next speech is about the composability of the rollups and brought to you by AJ Park from Radius. So please welcome him. Thank you.
Hi, thanks for coming. This is AJ, founder of Radius. I've been running ZK research community called ZK Soul since 2019. This Radius project actually came from this community. So I'm really happy to present here this project. Before we start talking about Radius, I'd like to introduce some thesis that I published a month ago, which is the modular first microservice. So with modular approach, we split one service into a number of specific features with modules. So in local module blockchain, there are DA, settlement layer, and execution, and also some kind of sequencing as well. But it's kind of natural in IT infrastructure from moving from modular approach to microservice approach, which means that we are going to split into more specific features, more micro level of modules. So there will be much room to optimize for these all features under their own circumstances. So we can provide a much better performance and also some kind of cost effectiveness for each module as well. So actually this happened in traditional IT infrastructure such as cloud service. So you can see here AWS that they split, they have many microservices like data storage to store data, and also some kind of gateway to handle a massive amount of conditions from user side. So or some kind of hardware that they can also optimize their own needs. But with this microservice approach, there are many modules to handle. So that's why they came up with some kind of concept of orchestration to coordinate this whole many rollups, many modules, so they can operate seamlessly and efficiently. So we can apply this kind of a microservice approach to blockchain space as well, because if you want to run rollups, there are many modules as well, such as wallet to handle your transitions, and sequences to build a block and all the transitions in the block as well, and then builders known as ME researchers to make blocks profitable, and then some kind of execution layer to keep the latest state of rollups as well. And then, especially for ZK rollup, there should be a proof, so to generate ZK proof to prove the integrity of state transitions in rollup side. So, as I explained earlier, we also need some kind of orchestration module to handle this, to coordinate these whole modules. So I think that sequences is kind of well positioned to coordinate them to operate in really efficient way. So that's why Radius is kind of focused on this sequencing side. So I'd like to talk about the rollup side, especially what's benefits. Right now, this rollup-centric theorem is kind of becoming real practical. There are certain benefits that you can get from this rollup approach. First of all, obviously the pre-confirmation, which means that rollups actually inherit security from the Ethereum. So rollups can actually guarantee some kind of pre-confirmation with their own, like a little bit weaker security. So users don't have to wait some kind of a couple of minutes for their transitions to be finalized on Ethereum. So this leads to a better UX for you, better UX. And another benefit that rollups give users is that a cheaper transition fee. Rollups batch transitions off-chain into one transition on Ethereum, so which means that the transition fee is going to be really low. So especially with the EIP 4844 to support block transitions. Recently, this transition fee for layer 2 is becoming much lower, less than 0.01 dollars. So, and then rollup central Ethereum is kind of becoming realistic, because right now there are many legit rollup framework have been open sourced. So like Mandara, there's a Starknet rollup framework, and then ZK Stack from ZK Sync, and obviously OpenStack from Optimism, and also Polygon CDK from Polygon. So you can use this rollup framework to deploy on your rollups quite easily. And then also there are many rollup as service providers such as Avail, so there are also things, so you can with one click you can deploy your own rollup in any ecosystem as well. But there are still some problems. Probably you are already aware of it, but almost all rollups, the existing layer 2s, are right now running the decentralized sequences at this time, which means that they can do whatever they want. If they want to censor your transitions or extract some kind of bad harmful MEV, such as front running or sandwich attack from your transitions, they can do that. They say they are not doing it, but there is no proof that they are not doing it. So that's why they have some kind of decentralized sequences on roadmap. And another big problem is liquidity fragmentation, which means that there is no efficient way for these multiple rollups to communicate each other. So you have different assets on different rollups. So if you want to move one asset on rollup A to rollup B, it's going to take some time. So that's why the fragmentation is a problem. Actually, this some kind of a bridge solution is to address this fragmentation of liquidity, but it just only supports this asynchronous composability between multiple rollups, which means that it's going to take some couple of minutes or even more time to finalize the transitions between multiple rollups, which means that it's really bad user experience. That's why the shared sequencing layer concept came up in this community, which means that these multiple rollups are going to share sequences to build a block. So, for example, you can submit flash loan bundle to shared sequencer, and then this sequencer is going to build up blocks for multiple rollups at the same time. So we can guarantee the atomic inclusion for the flash loan transitions. So we can make sure that these flash loans is going to be atomically worked, like transitions in flash loans bundle. All transitions in flash loan bundle are going to successfully executed, all of them are failed. So we can guarantee this synchronous composability between layer 1 and layer 2, or layer 2 and layer 2, or even we can provide this composability between layer 2 or with layer 3. So actually Radius is kind of focusing on composability between layer 1 and layer 2 because it's really interesting use case to support flash loans happening between layer 1 and layer 2 because there are many TBL already happening in layer 1 and layer 2. So Radius right now is building kind of a paper shared sequences, which means that Radius help rollups connecting with shared sequences. So we are not like us. We are not assigning any random sequences to rollups. Actually, rollups can select which shared sequences to communicate with them. We call it this sequences on demand service because rollups have each rollups have different requirements for their network, such as how to order transitions or the view about the MAD or or even a block time. So they have different conditions to run their sequences for themselves. And then after Radius providing this sequences on demand service, rollups going to pay Radius on our shared sequencer base. So we ensure the decentralization across the rollups, so we can generate the additional revenue from this service as well. So there are 3 kinds of sequencing service that rollups can choose. One is that decentralized self-sequencing, which means that some rollups might want to run their sequencing by themselves. So it's kind of a natural thing. But they need to find some way to decentralize these sequences somehow. So we can provide our unique feature such as censorship and resistance, and also we can guarantee liveness, so there will be no single point of failure with the sequencing service as well. Another type of sequencing is that cluster sequencing. After we talk with some multiple projects who want to deploy their own rollup networks, they want to just to communicate with some kind of selected rollups. For example, the gaming companies are going to deploy multiple rollups. They just want to communicate with each other, not like any other rollups outside of the company. So that's why we came up with this cluster sequencing thing. So we make sure there's composability within the selected ones. last sequencing type is based sequencing. Based sequencing concept has been discussed recently in the Ethereum community, which means that this sequencing will guarantee composability between layer 1 and layer 2. So based sequencing let layer 1 proposer to become layer 2 sequences to build a block for all layer 2s. So we can provide the synchronous composability between layer 1 and layer 2 as well. So I will talk one by one. First, various approach about this decentralized sequencing. We use encrypted method. There are many ways to decentralize sequencing, but typical one would be the consensus, having consensus model when building a block. But we think that is reaching consensus every time building a block would some kind of compromise this scalability, which is the ultimate goal of rollups. So we use encrypted method. So only one single sequencer is enough to build a block without manipulating anything or doing any malicious behavior on sequencing side, because user is gonna encrypt their transitions and then submit the encrypted transitions to the sequencer. Sequencer build a block without encrypting the transitions, which means that you can. So that's why we can provide MEV and censorship resistance for user side. And then before this sequencer decrypt transitions, they need to issue some kind of order commitments as type of pre-confirmation, saying that your transitions will be included in a specific type, a specific index of next block. So after this sequencer posts this block to Ethereum, user can easily find out if order commitment is kept or broken. If it's broken, user can claim, so this sequencer is going to be slashed. So that's how we enforce the MEV and censorship resistance on sequencing side. And then another one is that we use a leader-based sequencing, which means that, as I said before, we don't need any consensus model when building a block. So one single leader is enough to build a block. So we don't need to worry about this manipulation of ordering thing on sequencing side, because all the transitions are encrypted. So that's why we can use this crash fault tolerance instead of a Byzantine fault tolerance. CFT is much better and much efficient compared to EFT, so we can fully provide the maximum scalability for rollups. So how did we implement our encrypted method? 2 years ago, actually, we started Radius as Ethereum Foundation grants to build MEV resistant AMM. At the time, we came up with our own ZK scheme called PVDE, Practical Verifiable Delay Encryption, which means that when the user creates transitions, they also need to generate a time of puzzle. So the solution to time of puzzle will be used as an encryption key. So on sequencing side, sequencer side, they need to solve this time of puzzle to decrypt transitions. That's when the delay happens. So during this delay, these sequencers issue the pre-confirmation. So I explained earlier. So the PVDE actually provides a fully trustless sequencing, but the trade-off is that there are some additional computation happening on user side. So that's why recently we came up with this single key delay encryption scheme, which means generating time of puzzle and ZK proof happening on sequencing side, not on user side. So there will be only one single key for all users per epoch. So users have no latency when submitting transitions. So we are going to publish these articles quite soon, so you can read them through. So another one is based on sequencing. It's really recent concept. So it's just a simple idea to let this layer 1 proposer to become sequencers for all layer 2s. The composability between layer 1 and layer 2 is really important because of the censorship attack that might happen on layer 1 side. Like layer 1 proposer easily censor some blocks from layer 2 if they find out these layer 2 blocks are not economically aligned with layer 1 proposer. It actually happens, and then I think you're gonna surprised how often censorship is actually happening in layer 1 state. So the economic alignment between layer 1 proposer and layer 2 sequences are really important. So this base sequencing concept came up. So Radius is going to support this base sequencing thing as well. So we think that this opens some really great opportunity to make additional profit from some interesting use cases such as flash loans between layer 1 and layer 2. Okay, so, but as you see, the shared sequencers only guarantee is atomic inclusions, which means that it can only guarantee your transitions will be included in next block for rollups, but it cannot guarantee the executions. I mean, it cannot guarantee your transition will be successfully executed or not. So we have to make sure that every transitions in a cross rollup transitions are executed successfully, or none of them are going to be executed. So that's why we came up with our own way to support this atomic execution. It's already published in Ethereum research, so you can read them through. The point is that shared sequences are usually state-based, which means that we are not expecting for shared sequencer to execute transitions. They just order transitions, build a block without executing them. Because we want to support multiple rollups at the same time, so execution thing might be some kind of overhead for shared sequencers to build a block. But to make sure this synchronous composability, some level of executions are needed on shared sequencer side. But with our unencrypted mempool and cluster sequencing, we kind of make them practical to for shared sequencer to execute their transitions in their side as well. So I'm not gonna explain details, but you can read it through in the articles in your research. So the last one would be about the lower the finality cost. Especially for ZK rollup, these rollups is gonna generate ZK proof for their state transitions, and also it needs to post this proof and data on layer 1 to verify this proof. But the problem is they are really expensive. So some projects are really have really great idea about these aggregating proofs. So you can aggregate multiple proofs into one, so verification costs are going to be really low. And then another design that we are researching right now is the proof option. which means that we are going to support rollups to find the cheapest way to generate ZKP through this proof option, which means that we are going to communicate with multiple ZK prover networks in real time, and then whenever sequencer needs to generate the ZKP, we can trigger some kind of a proof option. So make sure the generating ZKP is kind of the cost for this generation ZKP going to be low as possible. So that's how we reduce operational cost for rollup side. So we can make sure that these rollups can sustain in economical way as well. Okay, so how we help rollups capture value? I mean, as I said before, it's really important for rollups to generate enough profits to run their networks in economical way. So there are two ways that we are going to support rollups capture accrual value. So one is that native token utility. As I mentioned earlier, we need some kind of a selection mechanism. So we can use restaking protocols such as Avail to set up sequencers for our sequence layer, which means that only sequencers who stake ETH, not native tokens of layer 2, can become sequencers for layer 2s. But which means that they're going to lose one of the biggest utility for native tokens, which is to secure the network. So this dual staking concept actually came from the eigenlayer. We also support this kind of staking. So if rollups wanna sequencers to stake the native token instead of ETH, they can do that. So they can have this really important utility for the native tokens as well. Another one is that MEV option gates. MEV is really a great source to generate additional profits from for rollups. So that's why we split our block space into two parts. Top block will be assigned to MEV searchers. So MEV searchers make a bundle with benign MEV such as arbitrage or liquidation, bank running, and then they're gonna put this bundle on top of this block so they can generate profit, and then these profits will go directly to roll side. Another one is a bottom part would include ETH transmissions from increased mempool, so we can protect users from the offline MEV as well. So that's why we are having this kind of design for roll sides. So for the radius progress, we already open sourced our encrypted mempool for Madara, which is the Starknet rollup SDK, and then we launched two testnets already. One Curie testnet with encrypted mempool, and then Portico testnet is it can show that liveness and leader variation sequencing for multiple rollups at the same time. So you can easily see that we actually made it. It's my personal belief that we are doing right way to make these rollups and Ethereum practical, and then I think the sequencing is going to be play a really crucial role for this modular approach actually become a major one. Okay, thank you very much.
So if anyone has questions, please feel free to ask him.
Yeah, so this is a very simple question. So how ideas handles some spam transactions because producing the ZK proof is, I think, it would be much more expensive than just posting a transaction.
To prevent spamming, it's kind of there are multiple ways to prevent spamming. One is that you have to put some kind of a minimum transaction fee. And then also with a PVD scheme, you just also generate a ZKP, and then this might cause for spammers to generate ZKP. So I think this kind of also some kind of way to prevent the spamming as well. So yeah, I'm not talk. I didn't talk about this transaction fee, but I think it's
yeah, and also just another question about the base rollups. I don't know very much about base rollups, but I think like sequencing through L1 would produce some performance issue. So does sequencer have some ability to resolve these issues or what else?
Base sequencing doesn't mean that there are only one server to support all rollups. They can have multiple servers, but the states that is sequencer has made is for Ethereum, so it's kind of a restated one. So
yeah, so if the transaction batch data is kind of published into Ethereum, then it should be at least finalized. Yeah. Okay. Thank you.
Yeah, if there's no more questions, thank you again for the AJ part, and we'll have our next speaker. So this is Raja Radun from Scroll, and he'll be discussing current state of developer experience in applied ZK. So please welcome Raza.
Sorry, David. Oh, perfect. All right. Hello, everyone. I'm Raza from Scroll. I lead dev role over there. If you don't know what Scroll is, it's a ZK rollup, a layer 2 solution, and we're here to help Ethereum scale. I'm going to talk today about applied ZK for builders, really developer focused, in the sense that if you've been working with generating zero-knowledge proofs for your application on the application layer, it's not necessarily been easy. And so this is me last year in Barcelona, where me and my team were hacking together on a simple ZK voting app, and we thought, okay, we got this. User logs in, we grab its credentials, wallet address, we generate a proof. Easy peasy, right? And then we verify it on chain. And then I found out that it's not really that easy. And so that's when the meltdown happened. If you're ever been part of a hackathon, you know this phase very well, where nothing works and everything breaks. So I've got a lot of full stack developer friends or devs that are coming into the space. And when they're like, oh, zero knowledge, cool, I want to do something, and then this is what they get thrown in. And, even the dev, we talk a lot about constraints. So, the constraint of uncertainty. And obviously that word makes a lot of sense once you're in ZK, but when you come from outside, it just basically means the rules that you apply. So when people talk about, imagine a front-end engineer or a full-stack engineer, even a smart contract engineer saying, hearing all these talks going on, they're new dynamics. And so that's very, very frustrating sometimes for developers because, it's a new dynamic to learn. So this next section will probably be very familiar for you if you're, into ZK, but if you're outside of ZK, when I tell people Scroll is a layer 2 ZK rollup, and we use zero knowledge proof to scale it, they're like, wait, I thought zero knowledge was used for privacy. So even the understanding of off-chain computation, zero knowledge, in my experience, it's very early. So right now, if you look at ZK, mainly two things. You have privacy, obviously, like, hey, I want to prove I'm Raza, I want to show you my ID, so I can use zero knowledge proof that. Or I want to prove to you that 1 + 1 is 2, but I don't want to show you the computation. I just want to verify that I did the computation. And so, what part of ZK is used for Scroll today? So this is going to be a primary if you're new to ZK. This is really simply how it works. So you always have off-chain a circuit. Don't run it on-chain. And what happens on-chain is a verified contract where you verify the proof. So what anyone could do then permissionlessly is check, whether if it's privacy related, the zero knowledge proof is correct. If it's computation related, the zero knowledge proof is correct. So what happens on chain really is just a verification. I hope there are no research that shoot. There are multiple things that you can do on chain. But the cool thing is that nowadays, there's a lot of development happening. But that also means that when you look at a rollup, it doesn't mean you can do, let's say, ZK out of the box on any rollup. Today, when you especially look at in the L2 landscape in EVM, you have these so-called types. I'm not sure, everyone's familiar with types, but you have rollups that are closer to being Ethereum compatible and further away from Ethereum compatible. This also means that not everything that you might need for a ZK or a DSL or an SDK might work on your role. So here, as a developer, these are the things you kind of need to consider when you want to use zero knowledge proofs and you want to pick a chain. You need to check, these examples, are all the curves that I want supported, hashing, precompiles, are they all there? And then also performance, because if you want to do anonymization, it has to be client side. We're still in the state where mobile app and development in Web3, isn't going really super fast. I mean, who here does all their transactions on their phone? Exactly. But when you check your bank payments, I mean, I'm guessing you do most of them on your phone. You're not going to open your laptop to send some money, I don't know, to whoever. And so mobile development really take off, but that's something to take care of. I want to give you a quick overview of all the tools that are sort of available. And tools maybe not the right word, but if you look at here, these are more like DSL and frameworks. I really like Noir. I think that Noir abstracts a lot of the setup away. If you look at the left, the ID, it's also, someone might call me out, for instance, Spruce ID, they don't use CKPs, but VCs verify my credentials. But this is sort of I tried to make an overview where you would have, okay, hey, what are the things I can do, ZK, all the things. Sindri is a pretty cool one, if you haven't seen it, because Sindri has the Python and the JavaScript SDK to deploy circuits and verify contracts. So very dev friendly. But generally speaking, you have two types of, let's say, tools, frameworks. They're purpose-driven and agnostic. So agnostic means I give you a language and you can build your circuits and you can set your rules and generate a zero-knowledge proof. Purpose-driven are usually for a specific purpose. It's an ID solution. So so a purpose-driven one is maybe you give an email address to an SDK, and then what you get out of it is zero-knowledge proof. But the zero-knowledge proof proves that, let's say, I am Raza, but I've never showed you my email address. But an agnostic one is like you give rules and code, so you write your circuit, you set up the constraints, and then you get according to those set up constraints zero-knowledge proof. So this is usually what I show hackers, and I'll be showing at ESOL this weekend. Is what is a ZK app? Usually very simply put, explain the concept of public and private inputs. What is a circuit? It's at the end of the day, it's just a program file. So it's a file that you can see that takes parameters, public private inputs, and then checks. You can assert, so just like maybe a test, so you check certain things against each other, and if it's correct, let's say Raza is
greater than 18, like older than 18, it generates improvement. And so this is usually how I explain again. It's more for hackers. If you want to get started, this is a good scope. You deal with a circuit. You need to deploy a verifier contract, and then nullifiers to prevent that a ZKP is used twice. Then usually go over the architecture, NOR circuit. I usually use NOR. I think it's very beginner friendly. Next.js and Solidity verifier. This is not important. This is usually the flow I show for a ZK code, ZK dApp. In this ZK dApp, you have, in the middle, you have an app. And basically, what this app does is, let's say there's an NFT contract to scroll, and you have a list of owners, and then you want to prove if someone logs in that you are you own an NFT. And this is what a ZK circuit would look like. So this is all the inputs that a ZK circuit would take. And if someone logs in with their email address or their wallet, they would sign a message. Circuit does calculation, sends a $0 proof, and then like an organizer could basically, or someone who wants to check it, okay, takes the $0 proof and verifies it on chain. Is the $0 proof correct or not? And that's basically, that was it. Thank you. Any questions?
I'm just curious, does ZK developers should need the very lower level of ZK service? Do you think so?
Do I think it needs lower level language?
Yeah. My question was that does a ZK developer has to know a very lower level of ZK circuits, like in an academic manner?
Yeah, so today, if you want to do anything that's performant and production grade, yes. The question being also should engineers know it? And I guess the answer is yes and no, depends on which camp you're. If you look at Web2 development today, it's abstracted so far away that most people that 7 years ago couldn't do like with Vercel click deploy. You had to set up a server, harden the server, all that stuff. So a natural transition would be I'm a big believer of that. No, it shouldn't. And so I'm a big fan of SDKs, where I do think in due time you'll have JavaScript and Python SDKs where you can write circuits.
Yeah. So I think to prosper the ZK environment, I think there should be much more abstraction on ZK. So.
Yeah, 100% I can agree with you. That's also why I like NOR. And in NOR, you still need to write, NOR is rustic, so you still need to write some Rust, but you only need to write the circuit. So no trusted setup, no commitment scheme, none of that. You only have the circuit. They basically have a backend that is pronkish, so you don't have to worry about setting up a proving system. You only write the circuit, and it has like a one-liner to also generate the verified Solidity contract. So you just deploy the contract, and it also has client-side proving, which also means that you don't need to deploy a server. So you have the circuit in your app, you can generate ZKPs and verify it on chain. So that's I think the best DevX at the moment.
Yeah, the last question is that for the developers who want to start ZK development, what language would you want to recommend?
Yeah, unfortunately today you won't get around Rust. The good news is I suck at Rust and I'm able to write circuits, so I think that you don't need to know a lot of Rust. But so for instance, I'm a Golang Python developer, and it took me a minute to figure things out. But I think Rust is you need to know the basics, and then there are quite, I would say, Sigri and NOR are your best touch points to start messing around with ZK.
Appreciate it.
Yeah, don't worry. All right, thank you.
you again for this speech, Raja. And up next, we'll have Pia Park from Herodotus, and she'll be discussing storage proof and HDP. I'm sorry for the delay, but could you wait for like 5 minutes?
나 없는데 그거 지금 0.1클릭.
아 옛날에 완전히 이직을 옛날에 이직을 쳤는데 완전 어디 졸려? 그 얘기는 지금 정말 알고 있었어. 근데 이거 주인까지 있어요. 주인님이 원하시는 게 아니 주인님들 아니 거기랑 그냥 사이즈가
Yeah, we're back, so please visit. We're about to start our next speech. And since we have our networking time at the end, so please save your networking activities for later. So we'll have Pia Park from Herodotus. And 여러분 저희 이제 세션 시작해가지고 다들 참석해주시면 감사할 것 같습니다. 그리고 마지막에 네트워킹 세션이 따로 준비되어 있어서 네트워킹은 그때 해주시면 감사할 것 같아요. So we'll have Pia Park from Herodotus and she'll be discussing Herodotus data processor. So please welcome Pia from Herodotus.
Hey everyone, I'm from Herodotus. My name is Pia, and today I'm excited to share about some alpha, which is we haven't announced in the official account. It's just we made it open source, and I leak on the alpha on my public account, like personal account. But yeah, it's just good time to showcase what we have been doing. Enhance the ZK off-chain compute to verifiable on-chain data using the ZK VM. So I want to focus on some problem, which is why we even care about all of this stuff. We want to solve the data access problem on the Ethereum. Why there's a problem? Okay, so first of all, Ethereum has a problem which is from and to any chain data access. So if you can imagine the traditional DB that you love in your old Web2 days, it looks like this. You can access the data from via one table to another table, which is very easy access, right? But if you think about scaled Ethereum one, which have a lot of rollups on top of it, which is the scaling Ethereum rollup-centric roadmap, but you cannot access the data very easily on top of hey, I want to get the startnet data on the optimism. This is not very easily doable right now. Yeah, so second of all, the problem that we want to solve is at any historical time. Currently, if you see the smart contract, Ethereum only saves the state of the current state. Meaning, you cannot access the historical state of some data that exists in on-chain. You cannot access, hey, I want some balance that existed in February 2022, something. It's impossible to do it right now in the current Ethereum model. And third of all, you can actually get all of this data using RPC or some trust party. But that's pretty much harming the Ethereum's basic philosophy, which is we want to access the data, we want to get the data in very trustless way. And you can actually say it as a verifiable way. I'll tell you later. So yeah, this is TLDR. This is how we want to access the on-chain data on the Herodotus that satisfy this string keyword from and to any location and at any historical time, and very trustless and also verifiable way. And this is the problem that we want to solve. And the solution that we come up is a storage proof. Actually, the storage proof itself is a terminology that we define some kind of a state proof. It's a very technical term, but it's something you can access the on-chain data in a very verifiable way. It's not very easy to understand at the very first step, so I'll tell you some one-on-one. So basically, the storage proof is Ethereum is pretty much
constructed into like many tries. As you can see the block, the header contains a lot of roots, and each root represents some like tries like root. And all of the tries combine, and these are the how the Ethereum is storing the data inside their blockchain. And meaning, because if we can actually retrieve some data A is indeed exists in this try, using some cryptographic commitment, you can verify the Merkle proof. This is not technical talks that I just explained high overview, but meaning that you can access any of the data that exists inside this tries, like state, receipt, transactions, meaning notes, gas price, the account state, anything that you can access in a very verifiable way. Yeah, so actually we have been developing the API for years, and right now we support the product that you can access the verifiable on-chain data via this asynchronous call. And we also have developed the Turbo. We launched the Turbo last year, which is you can able to get access to data via smart contract interface, and it can allow you to write those kind of script on the smart contract, and you can access any chain's data in any historical time in real time. So today I'm very excited to share something about Herodotus data processor, which is kind of little bit different approach that we took, but also basically it is based on the storage group as a fundamental. So ACP is a tool that allows you to easily define the large set of on-chain data, meaning a large range of the blocks, and run the computation, which is some average or some running a zk-ML, any kind of off-chain computation, over the very fully sound and proven environment. And we're using the Spark and storage group for that. Okay, so before what I just introduced, as in what we support as an API and a Turbo, when you want to compute something via storage group, via storage group one single slot, then you have to call the storage group of this 1, 2, 3, 4 slot, and you have to compute over the smart contract using the div. And this is pretty much expensive. And after, what we try to introduce in the ACP is you could actually just wipe out, block out this off-chain computation via not on the smart contract, but on the zk-VM fully sound environment, and then later you can just access the aggregated value on top of the smart contract, and you can trust that indeed this computation is performed very securely. Yeah, this is the idea. So it's if you go to this approach, when the data range becomes larger and larger, the computation cost will get tremendously high. So this is the approach that I want to discuss with the Herodotus data processor. And what I want to showcase some of the examples that we support. For example, first of all, dot sample data lake, which is I want to get this range amount of blocks, but the sample property, that every property that exists in the Ethereum chain, you can actually get all of this data using the Herodotus data lakes. And you can also fetch the data from the hey, I want to get all the transactions by a certain account from this node to this node. Yeah, this is the interface that how you define your own data data range. And yeah, if you know the dynamic data structure of the Solidity, every NFT collection, they store these owners and balance into some mapping. In this case, it's pretty difficult to get the slots. So we also support these easy accessible interface for those kind of dynamic layout storage data structures. Yeah, so after you get all of this data, you can do this kind of off-chain computation, which we already currently support in our open source product. And you could also like make a custom compute module, which is we are pretty much discussing this with the Giza, which is like they're supporting the ZK-ML, and we are like and modular sets and any other very heavy computation that they want to perform something via like verifiable on-chain data. And then they're very like interested in like using this kind of HTTP for their custom modules. Yeah, so like this is some use cases. Like you can do TOP because like as I mentioned, you can just like rate the what range of the block that I want to get. Hey, I want to like get the like all the blocks from this date until this date, and I want to get the information about this pool's like price, and then I want to make a like average. I want to get the average data from it. And basically, you can do all of this computation in your like smart contracts or like off-chain, like unsound environment. But what I, based on what I explained, is that you can perform all of these like values in a fully sound environment, which is right now we're leveraging the Chiral VM. Yeah, and then like this is some example of the like as a task that we define, and it's like a count function. If you know like SQL, then there's a like count function that defines some like, hey, if this condition happened, then you can select. And this is also like one of the examples that we're supporting. We can actually get the number of the cases when your average balance of the Ethereum dropped. And those kind of computation also like you can run in the fully sound environment. Yeah, so basically this is how it is structured. I was planning to like showcase the like demos and like some documentation, but since I don't have a like computer, so if you're interested, please check it out. The documentation is in like Herodotus.eth in the HTTP processor. Yeah, this was my yeah. So actually, we have like contracts and like the repo and documentation all in open source. So please check it out if you're interested. And thank you.
So if anyone has questions, please ask her about any details.
So I got like two questions. First of all, do you guys have plans to support like non-EVM environments? Because supposedly you guys are running a Chiral VM, so you would not be able to support like non-EVM environment to get like historical data proofs.
So basically, we are supporting the EVM and also like non-EVM only Chiral like StartNet. And because it doesn't matter, it's like Chiral program, Chiral VM is not like your actually okay. So here's the thing: StartNet is using the Chiral VM as their like proving like core feature, but you can use the start proof for EVM. You can use start proof proving system for like any other data computation. It doesn't have to be like, so if you can basically verify the Ethereum's Merkle try proof on the on the Chiral program, then yeah, it doesn't matter. It's just like a matter of the environment. Like for example, the meaning of the HTTP is like you can verify via like ZK VMs is because we're actually planning on like modularize those kind of backends, like as I just shared in it. So actually this, okay, so this is the part that we use the Chiral like program, and we put this proof into the prover. And this HTTP prover, you just take some proof. It doesn't care about like whether this is EVM or non-EVM. If you can verify it, then yeah, you can use whatever.
But I guess someone's got to prepare for the interface.
Which of the interface?
I'll ask later. So just skip on to the next question. Like, how much would it cost of if I say I want to get like a account balance of a certain token from like block number 200 million to 210 million. Like, what is like the average cost that an actual user would have?
Okay, so actually this part is like we are like pretty much optimizing the Cairo steps, because what the cost defined is in here the how much like proof cost to verify inside the Cairo program is the defining of the price cost of itself of this full like HTTP flow. So right now we're alpha. The meaning is like we didn't like launch for like developer, and we didn't have a like very strict benchmark yet, but we could say it's pretty much like cheaper than current like API if you running the same like 200 millions of like blocks at the same time. But yeah, we are like preparing for it. Thanks.
Yeah, it seems like there is no more questions. Oh, sorry.
So like I was aware of how like storage proof works when we're just considering a single chain. So like it's just the Ethereum, like the whole steps make sense because they're able to access like approvable access to like the recent 256 blocks or whatever. So I was wondering about like this is the first time I'm hearing about cross chain in a sense, like you can verify we get a storage access of another chain in another chain. So I was wondering how that actually works. Like, if I understand correctly, like you can call for like optimism's data in StarkNet or something like that, right? How does that work actually?
So pretty much like our interface is defined on the Ethereum, like the depend on the Ethereum. As you know, that like StarkNet, Optimism, and any other L2s, they settle their like state root inside the Ethereum for a certain amount of like period, right? And then you could actually retrieve those root, and you could so let's say you have a like valid root because you already get it from the like L1 contract, but assume that you have a like verified Ethereum headers inside your data like storage, and you could make sure that this header, like historical headers, are indeed valid. So how do we make sure about this Ethereum block header? Is basically we already running the like trains, like the Cairo program chains, like to submit the whole Ethereum like block verification program inside this shard. So right now we already have a like valid full Ethereum headers, and then now you have a like root that exists inside that header. So
So from what I understand, so if there is like sufficiently good connection between the main L1 and L2, this can be solved because you can just send the
if you can just like provide the valid root
to the L2.
Provide the valid root and valid proof, and you verify it because you already know the logic, how the verification happened in the like Merkle patricial tribe. Then you can indeed say, oh, this value is correct. And you can like submit the like valid root, L1, L2 messaging system.
Right. So I guess this does depend on the existence of L1 and L2, like between L1 and L2.
Yeah.
So if there's like, if you want to like support Solana for this, there would be some requirements of
I believe there should be the
message bridging between L1 and Solana.
Or the consensus like
right.
Yeah.
So those have to get into the mix if you want to fully do it. So since you can't like either like be as a KP or whatever, you can't get Solana data show it into Ethereum by itself.
Okay, so that's why our core like problem that we want to solve was everything happens on top of the Ethereum because it is scattered enough right now.
Yes, it seems there's no more questions. So thank you again for like this amazing speech Tia, and yeah, let's give her. Thank you. And since the next speech will be at 4:30, so let's have a short break for 20 minutes. So we'll be back at 4:30. Yeah, thank you.
제대로 벤치마킹 안 돌렸어요. 그냥 아직은 완전 알파고. 오피셜 계정에도 아직 이런 느낌이라서 그냥 디자인이
올리는 자신이 옛날에 헤드도 올리고 섭외해가지고 이치도 않았어요. 이게 왜 이렇게 찍어지면 이게 대물대로 네, 말도 안 돼요. 정신으로 왔어요. 거래소에서 거래 터진 물량을 연대가 얼굴도 외부
Can you hear me?
입사 그래서 면접 보자고 하고 나가서 끝까지 면접 보자고. 내 커피 먹었니? 아무도 차만 쉬고 있어서 돈을 버는 명이었는데 이런 되게 많더라고요.
맞아. 충격적으로 하지.
아니 나는 정한 기자님 말해줘서 알았다니까. 난 몰라. 이름을 안 모르니까 그냥 가가지고 롯데 이름 안 불러. 어제 봤어요. 히트가 3월도 들어온 거 같아.
진짜로 쇼크하는 것도
그렇게 되면 아까워. 인상 빨리. 그러니까 내 이름이 틀리지 않다는 아쉬움이
안녕하세요. 저희 대표님도
진짜 오랜만이네.
인사를 하는 거예요. 옆에 앉아있는데 우리 너무 옆에 앉아있는데 웃긴 거야. 그래서 인사를 했다 이러면서 우리 아까 예약 진짜 못해서 그래요. 난못 들어줘. 아니 집에
너무 좀 아프지 않나?
영어로 얘기하면 안 되나?
바람 붙여가지고
거기 영 하나 확실히 영 하나
그냥 저 저녁 행사가 있어요. 뭐가 있어? 아 그게 오늘 저녁이에요? 네.
저 가야 되는데 뭐 회사에
그러니까 여기 라이브 이거 스크린샷 올 전체 라이브. 자리에 없잖아요.
아 이게 블룸 미디어 잘했는데 시간 하셨지.
근데 아까 30분 있다 이상했는데 다 째면은 뭐 어떻게 괜찮아?
뭐 어떡해요.
이거 하나 들고 가세요. 티셔츠.
저요?
우리 하나씩 줬던데.
아 그래요? 그럼 제가 가도 되는 거예요?
여기 그 뭐야 미디어 파트너 자리에다 하나씩.
아 그거구나. 두 개가 있어. 왜?
저도 최본께 드려야겠네요.
그 사회생활 잘하시는 최고한테 줘야지.
최본? 근데 최본 이미 뭐가 엄청 많던데.
아 다른 명 오면 다
먹는 거만 뻗쳐 먹었어. 아 누가 먹었어. 되게 좋네. 아 재밌네.
나도 할 거.
나도 할 걸.
저한테 중요한 프레스 하고 내가 저한테
So, everyone, we still have our last two speeches. So please be seated, and we are about to start our sessions. Yeah, so the next speech will be about cross-chain interoperability brought you by Sean Lee from Axelar. So please welcome Sean. Thank you.
Hello, my name is Sean. I'm the head of Asia for Axelar. So I think I'm not too sure whether everyone knows Axelar. We'll do a quick introduction of what Axelar is about, but as the title suggests here, we want to connect 1,000 blockchains, and we believe in a very near future at the speed that we are going right now, there are thousands of L1s and L2s, right? So you can see every day on the crypto Twitter, probably there's another chain that's setting up. And how are you going to connect all these different blockchains? And for us, we believe, right, looking at where we are right now, all these different blockchains are very separated. Everyone is operating in silo, right? Maybe it's the L2, there will be a native bridge to Ethereum, but L2 to L2, how do you interact, right? There is that difficulty of interaction. So for blockchains to succeed is that every blockchain would have block space limitations, they have different characteristics, right? So essentially not every blockchain is purpose for a same purpose. You will need different types of blockchains out there in the long run when more economic activity comes in. So that's why we believe that there will be hundreds if not thousands of L1s and L2s in the coming future. And looking at where we are right now, and at the speed at where we are growing, we will need to see scalability to actually connect all the different blockchains out there. And if you look at right now the transactions, we believe in the near future, 1 out of 4 transactions will be cross-chain. Why is it so? Right now, if you were to open your application on your Apple iPhone, do you know that what kind of protocols are they interacting with the backend? You don't know, right? And if you're doing a transaction right now on Web3 applications, I think, for example, you need to borrow some of Avail, then subsequently go to Uniswap. You probably have multiple swaps and multiple changes of wallets and multiple chains of chains in your setting. So essentially, the user experience for a multi-chain world is very, very difficult. How can you abstract away, right? And our belief is that with more than 25% of transactions cross-chain, essentially you will need to abstract that whole problematic user experience away. And that's where Axelar comes in. However, you probably know that a lot of the traditional bridges had a lot of flaws, right? Some of the key areas were that they are not secure. Firstly, most of them have highly centralized architecture. If you look at the past as Ronin, Harmony, multi-chain, they were because of founders that hold keys, or it's just a very centralized multi-sig structure, right? I think this hasn't been a huge concern for users. Is everyone either go for the incentives, or the cheapest, or the fastest, right? But people are not aware of that security issue. And how can we solve that? The second part is scalability, right? A lot of the current providers are what we call as pairwise connection, right? So it's a one-to-one connection. If you connect 50 blockchains, you essentially will need to have more than 50 connections, right? Essentially, it's to the power of 50. But if we use a hub and spoke model, essentially you just need to establish 50 connections, which I'll show you later how Axelar solves that. Lastly, is the ease of use, right? Right now, a lot of interoperability players do not have the full stack ability, right? As an application builder, you will still need to deploy layers and subsequently choose, like, for example, the validation layer, right? So for that, it doesn't help in terms of the developer experience. So for Axelar, we are one of the top and most decentralized interoperability protocol. So we are essentially a platform, we are not a bridge. A lot of people kind of think of us as a bridge, right? I think traditionally bridges are just lock and main structure to move assets from one chain to the other. But Axelar is a general purpose message passing protocol where you can move messages from one chain to the other chain and compose different contract calls. And on top of that, we have a full stack interoperability, meaning at the top layer, we have different SDKs, different applications that are already built on top of Axelar. You can just utilize those SDKs and put on top of your VMs. I'll show you some later. The second key part that differentiates us versus other interoperability players is decentralized security, right? And I think that is the key thing for cross-chain interoperability. Why is that important? Is that if you look at, like I mentioned, all the key security incidents are all due to centralization. And how Axelar differs is that we ourselves are proof of stake blockchain. Other providers right now are mostly application layers, right? So they're just deploying endpoints and add some sort of like verification layer. And mostly only have around a multi-sig structure of 2 out of 2 or a 19 guardian network. You guys probably know, right? So there's wormhole layer 0, so and so forth. But from our perspective, we ourselves are blockchain. So if you know how a proof of stake blockchain works, essentially you will need the consensus layer, which is a decentralized set of validators. We have 75 of them. All of them are top entities, right? Lemniscat, the Figmas, ESRB, the Cosmos Stations of the world. All these and different entities runs the Axelar blockchain. Every transaction that goes through from, say for example, you're sending a message from Initia to AVAX, you will need to pass through a gateway contract that's already deployed, essentially like an endpoint. It then sends to the blockchain, the Axelar blockchain. The 75 validators will need to vote on that transaction. Once it validates the transaction, then it will send to the destination chain. Why is that so important? Is that for attack vectors to happen, is that you need to attack the set of 75 validators. And these 75 validators are validators on most of the major chains. So essentially, you're assuming more or less very similar security assumptions as the major EVM chains or other alternative L1s. Okay. And lastly, thirdly, is network effects. So from a hub and spoke model, essentially you're able to connect more chains in a much faster manner, right? It's a many-to-many connection instead of one-to-one connection. And most importantly, like I mentioned earlier, is that how can we abstract a lot of the cumbersome bridging process that you guys have, right? If you send a message from Avalanche to Optimism, you need to hold Avalanche, Axelar, and Optimism, assuming not using an Axelar bridge, right? But for Axelar, you just need to hold the source chain gas token. Everything else is abstracted away. And if you look at our current state of things, Axelar is that we are already integrated at more than 60 chains. Right now at 60, but we're going to have a few more coming up this few days, and we're already connected to the two major ecosystems, EVM and Cosmos, and we've already seen a substantial amount of increase in terms of transactions, right? These are organic transactions that are utilizing our applications and through a lot of the integrations that we have through Axelar. And this is very important that I'm going to pause there, is that if you look at the chart on the left-hand side, that is how the hub and spoke model works, right? So every transaction that passes through Axelar goes through the hub, which is Axelar, and send it to the destination chain. And I mentioned earlier how a lot of applications have been starting to build on top of SDK layer. So Squid essentially is a cross-chain DAX, right? Think of it as a bridge, but it's not your traditional bridge where it's a locking and mean structure. So what Squid does is that it utilizes existing liquidity pools on the different blockchains, right? So it routes liquidity. Take for example, right now you are swapping Matic token onto, say, the Glimmer token of Moonbeam. Okay, essentially what the so essentially it will source for the best liquidity on, say, for example, on QuickSwap. It will swap the Polygon token into USDC, and USDC will go through like a curve pool of Polygon and swap into Axelar USDC. And that's where the magic happens, where the message is passed from one chain, Polygon, onto Moonbeam. That's where the mint and burn, the burn and mint happens on both sides. Once it reaches onto Moonbeam side, it will swap into the USDC, the native USDC on the chain, and it will source for the best pricing on the deepest liquidity pools on the DEX stack. And all these are abstracted away from the user, right? It's a one-click experience that you guys can do within less than 30 seconds. And this is a very powerful tool that you see applications like DYDX, PancakeSwap, SushiSwap that have really integrated with Squid, and it's also utilized by top wallets like MetaMask, Trust, Blockchain.com, Token Pocket, you name it, right? Squid is happening in the back end that people do not know. Another cross-chain use case that we're building on top of Axelar is a cross-chain lending protocol. You guys probably will hear about Pike. I'm not too sure whether you guys heard Pike before. They are launching their token, right? But Prime has already been around for the last 2 years, right? So it is not a new idea of cross-chain lending protocol here. So essentially, you're able to actually compose different contract calls that you initiate a transaction. Take for example, you're using RepBTC on Avalanche. You're able to put that into, deposit that into a lending contract, and it will then update the state on Moonbeam. That's where Prime is built on top, where it's connected by Axelar, the message passing. You will then send over a message to Phantom side to initiate that loan, right, and create that mint approval. And once the lending contract is deployed, it will mean the stablecoin on Phantom side. So think of this as the base layer. If you think back, the last DeFi summer in 2018, you needed Ethereum needed the likes of, say, Uniswap, Avail, Compound to come out before you had new forks of these applications happening, right? Similarly, I believe that interoperability citizen or multi-chain applications is the next wave, right? Where people are able to build cross-chain seamlessly and not having you to actually move application to application. And one deployment that is happening right now is Uniswap X. I'm not too sure that you're following the deployment there, that they're developing something that has fully cross-chain experience that's highly seamless, right? So we are part of that project, and you will see more and more such applications that would be forming the new wave and the new native apps that going to push cross-chain experience. And as mentioned earlier, is that many of the top projects and even enterprises are really using Axelar. On the DeFi side, the likes of Lido, we are helping Lido to move stably onto Cosmos ecosystems. And also, we have a joint proposal with Wormhole to deploy onto BNB itself. Similarly, DYDX, Uniswap. Uniswap is an interesting case where they utilize Axelar as the cross-chain governance structure. And Frax, similarly, we have integrated with the Frexto chain, and we bring Frax, essentially Frax E, all their real assets onto multiple chains using our interchain token service, which I'll share more later, right? Other than that, infrastructure guys, like modular layer, I think this is the theme in this this workshop about Celestia, right? How we have Celestia as one of our key partners, where new chains that are working with Celestia will have interoperability through Axelar itself. And I think some of the key areas to highlight is RWAs, right? Real world assets. If you look at the bottom side, some of the top real world assets, Circle, USDC, On-Bill Finance, Centrifuge, and Provenance, they are really using Axelar to move and deploy on multiple chains. So think of it like right now, if you are aware, like Circle has CCTP. you are able to build a similar CCTV structure just using Axelar. That is what we did with Ondo, right? We're able to bring Ondo from Ethereum onto Mantle and onto new chains that they're going to deploy on. And lastly, for gaming, we're integrated with the likes of Decentraland, Immutable. Immutable is going to use us to create interoperable games and also having seamless user experience from an on-ramp standpoint, bringing assets from different chains onto Immutable chain itself. What are some of the key roadmap developed this year, right? To actually achieve our goal of scaling and also connecting up to 1,000 chains. Firstly, we would continue to develop new blockchain integrations. Right now, we are already connected to EVM and Cosmos, and we will continue to connect more non-EVM chains, right? The likes of Solana, Sui, Ripple, Stellar, zkSync, and Starknet, right? So essentially, we will have more and more non-EVMs that are added on the Axelar, and we have one of the most flexible stacks to integrate non-EVM chains. And if you look at other interoperability players, we have the widest coverage of ecosystems from Solana, the Sui Move ecosystem, and the EVMs and the Cosmos ecosystem, essentially enabling all different alternative L1s to actually interact with each other. The second part that I'm highly excited about is the ability to scale at a much faster speed. Right now, for every chain to integrate to interoperability players, they will need to actually work with the team itself, right? Essentially, permission basis, right? Everyone that wants to integrate a layer 0 or CCIP or wormhole, they will need to go to them and say that I need to build the endpoints. For Axelar, because we ourselves are our own blockchain, we have deployed our own virtual machine. That virtual machine enables developers of that new chain, the EVM chain, to actually deploy the endpoints without us coming to deploy that for them. So essentially, it's permissionless connection without the team to work on it. Essentially, it enables us to scale at a much faster pace for the EVM connections and also develop more and more non-EVM connections. And the other part will be on Q4 onwards is that we're also doing a lot of research on light clients where we're utilizing ZK proofs and also we stake ETH as security. And the last part is also something that it will be a great news for developers. Right now, as a developer, I'm not too sure whether how many developers in this room, I assume most of you guys are, is that whenever you build a new DApp on a chain, it takes, say, 3 to 6 months deployment time. How can you shorten your time as a developer and go to market at a much faster speed on 5 different chains, right? What we are building in Axelar is that with the infrastructure that we have, the virtual machine, we enable developers to actually build once, it can be chain agnostic, and deploy on 5 different chains, right? I'll show you an example of how we actually do that later. And most importantly is that with all the different infrastructure that we are building is that I would encourage more builders to actually look at the different interoperability protocols, choose the most decentralized one, and with the most developed dev tooling to actually help you grow and also scale onto multi-chain. And if you look at the different ecosystems, different verticals that are already building on Axelar, we have it all covered, right? For any developer or any teams that are looking for strong distribution across different ecosystems, we're able to support that. I'll just close with this note is that on the top left-hand corner, this is something that I really am very excited about is all the interchain applications. I've already shared 2 of them only, Squid and Prime, but there are many, 30 to 40 different chain agnostic applications that are building on top of Axelar. Right? That will be the new wave that bring across seamless user experience across multiple chains. With that, I'll just ask the team to actually swap to Axelar Twitter. I just want to do a quick demonstration of how this new tooling called interchain token service can help you deploy a cross-chain token, an interchain token on multiple chains with just a few clicks without coding. Can you switch to Twitter, please? Yeah. And go to Axelar Network. Sorry to show your Twitter account.
to do?
Oh, I told you it earlier. Give us a moment. If not, I can talk.
Okay.
Sorry, David, we need to like utilize the Twitter account to do it. Maybe you need to change your password after that. So I think why is this very interesting to see is that just like I mentioned about building once and deploying multiple chains, right? That whole infrastructure is going to change how a developer is going to think, right? Instead of now saying that I'm going to choose Polygon, AVAX, whichever chain, maybe whoever gives me the most brand, I'll go to that chain and deploy. But instead of that, you are able to build very chain agnostic apps and deploy on multiple chains very easily. This deployment, you just go Axelar and connect the work. Yep. The first video. So this is the first video here. Yeah, and expand it if possible. Yeah. So anyone can deploy that without any coding experience. So first you connect the wallet and you can put any token, right? LFG token, register and deploy, put the number of tokens that you want, connect your wallet, and click. Oh, you can select all the different 16 EVMs that we're supporting right now. You pay the gas, it registers the token, and you can see it will pop up all your token contract address, and all of them are consistent, right? The contract address and also the top token manager will be all consistent, be deployed on multiple chains. And subsequently, we are able to also whitelist that same token onto Squid, so you have the full access of moving your tokens across different ecosystems very easily, right? So, if you haven't tried that, you should look at it and check it out on our website.